When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, and communities celebrate. Awqaf South Africa, a charitable Awqaf organization, makes it easy to share the care. All donations are ploughed into Sharia-compliant investments, while the fruits support a wide variety of charitable causes. Visit awqafsa.org.za to discover how your Awqaf can bless our community with a legacy of care.
We start in God's name and we ask Him to bless the session, assist all our grade 11 learners, our educators, our parents that are supporting us, and may God ensure that we have a session that is productive, that assists our learners during the session. Assalamu alaikum wa rahmatullahi wa barakatuh, Sawubona, Molo, Goeiemorgen, and a warm welcome from all of us here from Awqaf South Africa. It is indeed a pleasure to be joining you during day 2, and we are going to be focusing on grade 11 maths today. We will be focusing on support around geometry. Mr. Kota is going to be taking you through the session to assist you to prepare you for your June examination. So if you have any concerns, any questions you'd love for us to focus on today, rest assured this session is going to be here to assist you. My name is Hasanain Abdullah, and I'm from an organization called Awqaf South Africa, and we are a community organization, and we support our community through sustainable projects. Some of our projects include providing water through our ball project, where we set these balls up at community centers. We restore the eyesight of blind people through our cataract project. And this project, our maths workshop project, is focused, it is a part of our focus in education development, and we've been doing this since 2016. So you are most welcome to join us during the session today. So we had a successful session yesterday where we focused on maths paper 1. It started at 9 o'clock and went all the way to 3 o'clock. So look in this video, look in the description, and we'll post a link to that video in case that you have missed that. So it is indeed my pleasure to introduce and bring on the session Awqaf SA's CEO, Mr. Sadiq Isaacs, and he's going to be addressing us with a few words. Assalamu alaikum, Mr. Sadiq. Take it away.
Alaikum salam, hasanain, and thank you for that introduction there. I greet you all with peace and blessings, and a very good morning from a beautiful Sunday morning in Johannesburg, and I'm sure all around the country. Whether it's rainy, windy, whether the sun is shining, it's always a beautiful day to be able to share things with other people. And this morning, Awqaf is proud to present another maths workshop. And today it's paper 2. And I'm sure our colleague Mohammed Kota is going to go through all the necessary with you when he starts off. But I'm warning you this morning if that energy that I saw yesterday is anything to go by, you're in for a very, very good day, and certainly a very exciting day. And I'm certainly going to log in later on and just try and absorb some of that energy, because I can tell you, when I logged in yesterday and I saw what was going on, I was really, really not only impressed, but I was energized. And so anything close to yesterday, be prepared, have enough water, have enough refreshments to keep you going through the day. But I think you're in for a very, very interesting, exciting, and a very learning day that will stand you in good stead in terms of your education. Awqaf is committed to this workshop. We certainly are very appreciative of the expertise of Mr. Kota, who certainly brings a very different dimension to mathematics. And certainly, I am absolutely certain that you're going to see the benefit of this as you go forward. At the same time, this is important for Awqaf, because we are an organization that is involved with the community on very different levels. From a social cohesion point of view, we do a lot of downstream projects that involves very different things. As hasanain sort of started out with, we're involved in sport, education, we're involved in training. We've got a training program that is run by one of our colleagues. So Awqaf is certainly involved in quite a number of things. One of the important aspects that we want to remind you is that after all of this, there's going to be a great competition for you. And Awqaf SA will host the competition for all participants who take part in the grade 10, 11, and 12 maths workshops. It is open to all registered participants, and you will receive an email to enter. And the competition will be open in January 2024. That's obviously after all the programs have been run and you've done your examinations. And once the grade 12 results have been released, there will be cash prizes that will be awarded for first, second, and third prize. And we're also looking at one or two other things that we might add to that. And we're thinking along the lines of possibly one or two laptops that will be added. And we will also look at the most improved results over this period of time. So details of the competition will certainly be posted on the Awqaf website. So watch out for that. Remember that. Make a note of it. And then remember to register and to join us for this competition. But now that you've heard enough from myself, I think the man of the moment is about to take you on a very energized road today, and a journey that is certainly going to stand you in good stead. So a big thank you to hasanain, a big thank you to Mr. Kota for again joining us for session 2, and I hand back to my colleague hasanain.
Thank you there, Mr. Sadiq Isaacs. He will be joining us later on for the concluding remarks. But we have this video insert to cue in Mr. Kota, the man, the myth, the legend. We've been working closely with Mr. Kota since 2016, but it's been indeed an honor working with him since 2021 on this online version of the workshop. So we're just going to cue in this short video insert. Mr. Kota conducted a maths workshop at a school in KwaZulu-Natal, and we just want to raise that energy a little bit high to cue in Mr. Kota. Oh man, doesn't get better than that. Assalamu alaikum, Mr. Kota.
Walaikum salam wa rahmatullahi wa barakatuh. Hasanain, do I need to put on my headphones or is this okay for now? Can you guys hear me? Can you and SA hear me loud and clear?
Yes, we can. We can hear you loud and clear. Mr. Kota, let's get the show on the road. Let's try and match the energy of yesterday. Before we get started, what is required? And let's run through the program. Let's get that up on the screen in terms of what is required in order to make the most of the session today.
Good morning, good morning, good morning, one and all. I hope you guys are bright and fresh and early as me this morning. And I'm on my third cup of coffee already, so you know we're boosting. Make sure that you are hydrated. Make sure you have nutrition. Make sure that you are not hungry, that you are eating while you're learning. I didn't mean free so that you fall off to sleep, but just have enough in your body to keep you fueled for today's bumper session. So yeah, welcome everybody. We need the scientific calculator, exam pad, your writing instruments, pen, ruler, and please make sure that you are gimbaing lekker through the entire session for today. Water being an essential, sandwiches, snacks, fruits, nuts, anything for brain food. But the biggest brain food today is math. That's the biggest brain
But
food.
not slap chips and hike
No,
and snook and then we're going to sleep.
Gatsby's and AKs and you, bro, that thing there makes you lam, Alif.
But I had a half a Gatsby yesterday. You know, you kept me on my toes, but that half a Gatsby kept me going before lunchtime.
Yeah, no, I told you I was just boosting on coffee and samosas the whole day. I needed something light. Remember something, the more you eat, the more your body is going to sort of tap out. And then you're going to see my face becoming bigger and smaller, bigger and smaller. Some of you might have dreamt of me last night. Well, Kway, I dreamt of you too. Right, so let's go. Exe ahoy. Stross, you are back. Euclidean, yes. What we're doing, guys, we're finishing up yesterday with the functions. We finished off with the parabola. We finished off on a killer one. Before we go into tricks, guys, I just want to finish up the functions. Let's do the hyperbola with the shift and exponential. And then we'll finish up with the functions and we'll kick straight into trigonometry paper 2. So as the name, we're ready to launch. Has our launch sequence already been initiated?
Hi, Captain Houston. We have
Houston, Bismillah. We start with the universal Arabic phrase, Bismillah ar-Rahman ar-Rahim, in the name of God, the most gracious, the most merciful. Take us away. Send us our launch sequence. And let's get fired up.
3, 4, 2, 2, 2, 2, 2, 2, 2, 2.
Danko. Are we playing that insert?
We
go straight into it. You played it already? Oh, man, I missed that.
You want me to do that? Okay.
One more time.
One more time.
Play.
We're T-minus 10, 9, 8, 7, 6, 5. We have to go from ready to start. 2, 1, 0. Booster ignition and liftoff of Shuttle Endeavour with NASA's final space station crew compartment that brings a bay window view to our celestial backyard.
Take us away.
Lovely. You know how I love that.
Take us
And
away.
especially that caption that says our celestial
My
backyard.
rocket is launched.
Moving along. Let's get started. Good morning, one and all. Learners, teachers, parents, and the rest of South Africa learners in house. Let's do this. Everybody's bright and fresh and early on a Sunday morning. Let's go. Let's take it away. Let's clear the frame. Guys, we stopped yesterday with the parabola. Put the heading, the hyperbola. Now, this you've been introduced to in grade 10 already. So if I told you h of x is equal to 4 over x. Right, let's sketch the graph. Number 1. Number 2, let's give the domain of the graph. Let's give the range of the graph. And let's give the equation of the asymptote of the graph. I hope you guys remember what does asymptote mean. I know there was a lot of information given yesterday. Answer. So take this one down, guys. Now, I know you guys use your calculators for this. Some of your teachers show you to use your calculators. I'm going to show you another way quickly. I like using the table method. For me, it works like a bomb. right? I don't even know, as a Muslim, am I allowed to use the word bomb? Bomb must be taken out of my vocabulary. So X and Y. So we got 0. What do we put for X? You put the positive and negative about 3 factors of the number 4, of that number. Your standard form is A over X. So I'm going to go 1, 2, 4. Any 3 factors. That's the positive. Now let's do negative. -1, -2, -4. Let's plug in these values for X to get our corresponding Y's. I know your brains are bright. Your brains are clear. They are fresh. You know exactly what we're doing. So 4 over 0, undefined. 4 over 1, 4. 4 over 2, 2. 4 over 4, 1. 4 over -1, -4. 4 over -2, -2. -1. Let's go and sketch our graph. Sketch the graph. Right, your first point, 1 and 4. 1 on my X, 1 on my X, 4 on my Y. 1, 2, 3, 4. That's your first point. 2 and 2. 3, 4 and 1. We join those dots. Make sure it's a curve. And then -1, -4, -2, -2, -4, -1, and join those dots. And there we go. That's your x-axis. That's your y-axis. Okay, there we go. We sketch the graph. We call it graph H. And we're done. Easy peasy. So step number one, draw a table. Put 0 in the middle. Put positive and negative 3 factors to the right and to the left. Positive to the right, negative to the left. Substitute them for X and put your corresponding Y's. These are all your coordinates. And sketch your graph. Join your dots. Join your dots. Right, let's see. Let's see how's our comments coming in. How are you guys doing there? Good morning, Lihle, Manchkan, Umaira, Lachman, Rendani, let's get it. Morning, Tobeka Tele, Lenzil, Ayanda, Gladla, Siabonga, Tombel. Hey, Fazila. Hello, Fazi. Fazila is in. Let's go. Kennyville. Let's go, guys. I hope you've taken all this down. What is the domain of the graph? Domain refers to X. Which X value? Any negative value, any positive X value, but not 0, because the graph won't touch 0. So the answer to question number 2 for the domain, you can say -infinity to +infinity, but X not equal to 0. You can write it like that. Or you can say X, the domain, X less than 0 or X greater than 0. Or you can say, you can write it in 3 ways. You can say X is an element of real numbers, but X is not equal to 0. And there we go. We've answered question number 2. I've given you 3 different ways in which to write your answer, as long as you don't include 0 in your answer. Why? Because your y-axis and your x-axis are your asymptotes. Hello, Vuchila Mongani, Keima V, Vuchila, Masyodi, Masedi. Hey, how's it, guys? Nice to see you guys this morning. We're now going to be doing the hyperbola with a shift in asymptotes after this. We're going to be doing the hyperbola with a shift in asymptotes after this. Let's do the range of the graph. The range are your y values. Domain is X, range is Y. So the answer to question number 3, any negative Y value, any positive Y value, but not 0. So Y is an element of real numbers. Y is not equal to 0. Or you can say -infinity to +infinity, but Y not equal to 0. So you can write it like that, or you can write it like that. No problem. How's it, Romana? How's it, Yusra? Good. Welcome, Zain. Welcome, Zaid. Our in-houses also here, fresh on a Sunday morning. Let's go, let's go. The equations of the asymptotes. Answer to question number 4. So the equation, your x-axis is your one asymptote and your y-axis is your another asymptote. What is the equation of your x-axis? Tell me, what's the equation of your x-axis? Y equals 0. What's the equation of your y-axis? X equals 0. You must write it like this. There we go. And that's it. It's simple. You know, if A is positive, it's in your first and third. If A was negative, the graph would be in your second and your fourth quadrant. Are we all okay? You all following? Can we move along? Let's go back to StreamYard. Feeling fresh, I told you, yesterday you were buggered, today you are fresh. We got lots of work to do today, guys. Too much work to do. But yeah, we're finishing 6 months work in 2 days. Lots of love coming here from Joburg. We got a beautiful morning here. I hope wherever you are, you're having a lovely, lovely, lovely morning. Thank you, Kema. Thank you, Kema. Let's go. So you all got this? You've taken it down? What if the hyperbola was given? Now listen, I'm going to show you guys a shortcut. Here's another hack for you. Check this out. Check this out. So say you went to your exam and they gave you a hyperbola like that. And they gave you a point here and they call that point T, 2 and 5. They call this graph H. And they say, question in the exam, find the equation of H. And it's only worth 1 mark or 2 marks. Find the equation of H for 2 marks. This is your answer. I'm showing you a shortcut. I'm showing you a shortcut. So you start off, H of X is equal to A over X. There you're going to get 1 mark there. That's your standard formula for hyperbola. So therefore, H of X, I'll show you how to get your answer in 1 step. All you do is you multiply these two. 2 times 5 is 10. Game over. Why, ne? There's your 2 marks. There's your 2 marks. Bet you never saw that one coming. I bet you never saw that one coming, Strauss, Waffles, Rendani. I hope you guys never saw that one coming. There's the shortcut. You just multiply the coordinates. That gives you your A value. How's that? Thank you, Waffle Skater. Good morning, Mr. Kota, and every onliner. So guys, check here. Check this out. Check this out. So even if I gave you a graph, let's do another graph. Say I gave you a graph in this quadrant here. Say I gave you a graph in that quadrant there. I call that graph H, a graph G, and I call this point R. And I tell you that is 3 and minus 5. Give me the equation of G. Come on. G of X is equal to, just multiply the 2, minus 15 over X. Game over. Kway
Mr. K.
You're Mr. K. I know you don't speak like that. I speak like that.
Yeah. Mr. K, just a reminder to the learners. Kindly subscribe to the YouTube platform. We will be conducting workshops as prelims as well as the final examination. So if you do subscribe to the channel, you would get a notification of our up-and-coming workshops. The same applies to those connecting via Facebook. Do like us on Facebook, like this video, and also give the Facebook page a like. So in this way, you would not miss out on Mr. K and his actions. Over
guys,
to you.
I hope you guys are loving the session. I hope you're learning all these tricks. Thanks, Sagzoman, Klauleko, Telani, Gati, Jacques Runaval, and everybody else. Right. So this is how you can be smart in your exam. This is how to finish your paper very fast. Right. Let's go. I'm clearing the frame. I'm clearing the frame. We're now doing the hyperbola with the shift in asymptotes. 100% you're seeing this. After you do functions in your paper, 100% you'll be getting one like this. So we are now going to be doing the hyperbola with the shift.
Question.
Let's see. Let's go back to StreamYard. Yeah, you can. Yes, you can. But that was the shortcut, Stross. You can. No problem. You choose what you like as long as you get the same answer. I just show you different strategies. You tell her what you must, bruh. Tell her whatever floats your boat. Whatever floats your boat. I never use that table on the calculator ever for anything. I just use my own little shortcuts, my own little hacks. Boom, boom, bang, bang, bang. That's how you can finish a 3-hour paper in 1 hour. You can do the same paper 3 times, Baba. When you finish, you don't say, I think I got my distinction. You say, I know I got my distinction. This is the time to clap maths hard. We're here to destroy math. Let's go back to the Jamboard. Now we got h of x is equal to 4 over x minus 1 plus 2. So there's your normal 4 over x. Now we're shifting it. This is given in the form a over x minus p plus q. What is p? Somebody asked me yesterday, what is p? That's your x asymptote. But you change the sign because of the negative. So if it was minus 2, your x asymptote would be plus 2. So here it's minus 1. So it will be, remember, you've got to change the sign. Why do we change the sign? Because the original's got a negative. And plus q, positive doesn't change the sign. That's your q is your y-s. But you leave the sign. So how would the questions be asked? Right. Question number 1. They want the equations of the asymptotes. Question number 2. They want the intercepts of the graph with the axis of the function with the axis. Question number 3. Sketch. Number 4. They want the equations of the axis of symmetry. Let's do it. So what's the equation? All right, take this one down. Why are we doing it? Let's just go through some of the comments that are coming through. Guys, hit us up in the comments. Let us know how you're feeling this morning, where you are joining us from.
Question.
Yes. How many marks is this question? Right, let's give you mark allocations here. Bra, exe, bra. Let's go back here. Exe, meneer. Meneer van Kakamas. You guys know Meneer van Kakamas?
Hey. This guy is hilarious.
He's in Pakistan. But he speaks, he's a Pakistani, but he speaks Capetonian Afrikaans, bruh. He's a boss. Equations of the asymptotes, 2 marks. Equations of the functions with the axis, 4 marks. Maybe 5. Maybe 5. So we can even go up to 6 marks for that. Sketch the graph, 3 marks. Equations of the axis of symmetry, another 4 marks. 6 and 4, 10, 15 marks on this, bruh. Kom meneer, kom ons dala away. Die meneer van Kakamas. You don't change the sign. Bochoko van Wyk, you don't change the sign of Q. You leave the sign. I'll show it to you now when we're answering. Bochoko. Hey, good morning, Commander. General Mikenzo Chauke. Good morning. Nice to see you guys. Nice to hear you. Let's go. Right, Mulisa. Let's dala this. Let's crack it like a boss. This is an exam style question. Equation of asymptotes. So that's your x asymptote. -1, but you change the sign for x. So the answer to question number 1, let me take away the mark allocations here so I can put the answers next to it. Or in fact, what we do, let's do this. Here at the bottom. The answer to question number 1, x is equal to 1. That's your equation of your 1 asymptote. -1 becomes +1. And then y is equal to 2. That's your p value. That's your q value. I hope that answers your question, Boy Choco. Dango MK Machaba. You know my initials are also MK. Return of the Mac. I'm MAK. Number 2, the intercepts. So now we're going to say let x equal to 0. Let x equal to 0. So when x is 0, let's find out what is y. So that means y equals 4 over 0 minus 1 plus 2. Y equals minus 4 plus 2. Minus 2. And now you're going to say let y equal to 0. Let y equal to 0. So that means you're going to have 4 over x minus 1 plus 2 is equal to 0. Let's solve for x. 4 over x minus 1 equals minus 2. I'm just going to move up here. 4 is equal to minus 2 into x minus 1. Remember, we cross multiply. Let's solve for x here. I'm just going to move here at the bottom. 4 equals minus 2x plus 2. So minus 2x will equal to 4 minus 2 is 2. X is equal to minus 1. So that means minus 1 and 0. That is your other intercept. So your first intercept, gas, is 0 and minus 2. And the other one is minus 1 and 0. And there we go. You show all calculations. Let x equal to 0, solve for y. Let y equal to 0 in your equation and solve for x. Right, Zaid? Right, Zain? Right, Romana? Right, Yusra? All of us okay? Amanda Chauke, you feeling great? Are you learning? Are you understanding all of this? Thanks, Boy Choco Funvik. Thanks for engaging with us, talking to us. Don't worry, guys. I am going through everything on the side. Yes, we are going to be doing paper 2 today, not quasi. I'm just finishing up the functions from paper 1 from yesterday, and then we go straight into trigonometry paper 2. Right. Excellent. Right. Let's sketch the graph, guys. Let's sketch the graph. Let's sketch the graph. This is marks for jam. So please make sure you know your work. Let's sketch the graph. So I'm answering question number. So we did question number 1. We did question number 2. We're now doing question number 3. So let's go to our graph. Let's do that. Right. The first thing you do is you put in your asymptotes. Right. X equal 1. X equal 1. There's your x asymptote. There we go. Y equal to 1, 2. Your asymptotes actually shift your entire Cartesian plane. So your Cartesian plane is no longer at 0 and 0. Your Cartesian plane is at 1 and 2. Your P value and your Q value. Your P value and your Q value. Remember, for the X, we change the sign. It's the rule. And for the Y, the Q value, we leave the sign. Now our first point, 0 and minus 2. 0, minus 1, minus 2. That's 0 and minus 2. That's your first point. That's your first intercept. Minus 1 and 0. That's minus 1 and 0. And that's 0 and minus 2. That's your other point. Let's sketch the graph. All we do, we join the dots. We join the dots, making sure it doesn't touch your asymptote. And you know, if this is positive, it's in your first and third quadrant. And there's your first quadrant. Just draw it there. They're not interested there. They're interested in the points where it intercepts with your axis. Okay, we're almost done here. We almost done. We are almost done here. There we go. There we go. I think that's better. Can you see that, Nunu Berry? I think that lower third was covering what was there at the bottom. Can you see now, Nunu? You so Nunus. Nunu Berry. Let me get a name like Nunu Berry. Nunu, are you all right there, Nunu? Talk to us, Nunu.
I think that's a good name, Mr. K.
Nunu. So Nunus.
Okay, feedback.
There we go. I wanted it to come a little bit down. There we go. I'm checking your comments. X asymptote written vertically. X asymptote written vertically, correct. Y asymptote written horizontally, right? Right. Correct. Correcto mundo. Telani. Hope that answers your question. Good. Talk to me, guys. Talk to me. You guys, your conversations keep me flowing. Hey, Give Gamer in the house. Where did you put your Give Gamer? Which rock you crawled out from this morning? Bryce still sitting there under the duvet with his coffee doing maths. Where?
His tires got popped yesterday.
Question number three. We sketched the graph. So we put in, so to sketch the graph. So, okay, she wanted to know to sketch the graph for question number 3. Step number 1, you put in your asymptotes. There's your asymptote. X is equal to 1. Y is equal to 2. There's your asymptotes. And now we just put our 2 points with the intercepts with the axis. -1 and 0. There we go. -1 and 0. 0 and -2. We join the dots, making sure it doesn't touch your asymptotes. Simple as that. If the graph is touching the asymptote for snare, 0, baba. It can never touch the asymptote. The graph must never touch your asymptote. Get that in your heads. Get that in your head, snare. It must never touch your asymptotes. Haram. You will go to Jahannam for that, brah. In math. Math Jahannam is called rings in your report. Right, the equation of the axis of symmetry. We're answering question number 4. Now, let me explain to you. Put your pens down. What are your axis of symmetry? Put your pens down. Let's go through your axis of symmetry. So let's go here. Let's bring that down. Your 2 axes of symmetry. Remember, axes of symmetry are straight lines given by y equals mx plus c. So your first axis of symmetry will go down like that. And your second axis of symmetry will go down like that. Now you know this is a negative, so this is y equals minus x plus c. And this is the graph y is equal to plus x plus c. So this is the one with a negative gradient. This is the one with a negative gradient. And this is the one with a positive gradient. So we need these 2 equations. And look where they go through. They go through your P and Q. They go through your asymptotes. They go through 1 and 2. These are your 2 axes of symmetry on your graph. Are you all following me, onliners? Are you? Okay, meaning when sketching, they only look for 2 things. The asymptote and the intercepts. Correct, Kema. You are absolutely. And if it's positive, it's first and third. Correct, Tina. Absolutely right. Thank you for learning. Super easy, Baba. Super easy. Thanks, Letlokonolo. Right behind me. Now we need to give these 2 equations, guys. Watch here. This is the way you do it. So firstly, in your answer, I'm answering question number 4. You put y equals x plus c. Then you put y equals minus x plus c. The point that we're going to use is 1 and 2. We need to find out c. So all we're going to do is going to say 2 equals 1 plus c. So c is equal to 2 minus 1 is 1. Your first equation with a positive gradient is y is equal to x plus 1. That's your first one. Let's do the other one. 2y, there's y, is equal to minus x plus c. So c is equal to 2 plus 1, which is 3. Your next one, y equal minus x plus 3. There we go. That is, sometimes they might, if they don't specify, you give both. If they specify equation of the axis of symmetry with a positive gradient, then you only give this one. If they say with a negative gradient, you only give that one. So there we go. That's the one with a positive gradient. There's your answer. This is the one with a negative gradient, and there's your answer. Finish. And you got yourself 4 to 5 marks for that. Marks for jam. Marks for jam. How many times am I going to say asymptotes? You're a million times, bruh. You don't know how
asymptotes.
asymptote, asymptote. Yeah, ne?
Little grumpy there, I see, Mr. K.
Yeah, good morning. So there's your 2. Y is equal to x plus c. It's your asymptote with a positive gradient, and you put in your P and Q and you solve for C. So this is your asymptote with a positive gradient, meaning the positive gradient. Here's it. It means this line here, its equation is y equals x plus 1. That's that one there. Then with a negative gradient, that's this line here going in this direction. And its equation is y equals minus x plus 3. And that's how we do our calculation. Positive gradient, negative gradient. Are we good with that? I hope that answers your question there. Do you draw the straight lines where the asymptotes intercept? Yes. That's only if they ask you to sketch the asymptotes. That's only if they ask you to sketch the asymptotes, the axis of symmetry. Okay? And there we go. Our 2 axes of symmetry. These are the equations of our axis of symmetry. The one with the positive gradient, the one with the negative gradient. Y is equal to x plus c. That's that one. Y is equal to minus x plus c. We put in our asymptotes 1 and 2 for x and y. And there we go. All right. That's done. What if the reverse is given? What is the reverse? So should we first draw the asymptotes before plotting? Of course you should. That's the first step. You put in your asymptotes. It's in this one. You put in your asymptotes. Number 1, you put in your asymptotes. Then you put your intercepts. So let's write it out. You guys want to know what the process is? Let's put the process down for you. Let's erase all of that. So to sketch your graph, here goes. Let's put the steps to sketch your graph. Whoa, no, let's get that out. Let's go with our eraser in there. Right, so let's write the steps out for you. Steps to sketch. Step number 1. Put or draw your asymptotes. Put in asymptotes. Number 2. Plot your points. Plot your intercepts. And then join the dots. That's it. The axis of symmetry, you only draw. So only draw axis of symmetry if the question asks. It's not generally part of your graph. So these axes of symmetry, you'll only put it in if the question asks. Other like this, where it asks you for it, to give the equations and then sketch in your axis of symmetry. But to sketch the graph, put in your asymptotes, plot your points. I hope that answers your question. It's in this one. Did I answer your question, bruh? So what if the reverse was given, guys? You guys going to be given a chance, so either to sketch or maybe the graph is given and you need to find its equation. So now put the heading, finding the equation of a hyperbola. We're almost done. We're going to do the exponential and then we are done. Got it, give gamer. Got it. I'm loving your comments coming in here. Some of you are hilarious. I can't read all of them.
Mr. K, you remember Bernadine Olivier? She was on
Yeah.
our session.
Hey, Bronadine.
She's a legend.
That's a legend from the Northern Cape. Funny Cup.
From 2022's workshop.
How's it, Bronadine?
Another
How you doing?
ambassador of our project.
Now look at Sindile. How do we sketch a trig function? Are we doing trigs or are we doing functions, bruh? Yo.
Like Lankif, bro.
Okay. Let's go.
That's a fine, Mr. Kota. That's 50
That's
rand
a fine
for
red
me.
card, except
50 rand to me. I can buy myself.
$50 going to you.
Can
I
go
forgot
to
put my
Kauai.
phone on.
No, send that money
There we
first.
go. Right, let's go. Now, if I gave you a graph, take this one down. Let's say I gave you a point here. I gave you the one asymptote is 2. I gave you the other asymptote here as 3. I give you a graph, and I tell you the graph looks like this. This is graph H, and I call this point T, and I tell you that is 4 and 6. I tell you the following graph is given. So find the equation of H. I want the equation of H for 5 marks. The equation of H. So now the graph is given. So here's your answer, guys. Okay, take that one down. Take that one down. There's Bronadine. Just love our work. Thank you. We love you too. Thank you, Kutluano. You were struggling with this. Now you're understanding it. No problem, Lazarus. Load shedding is coming. And you'll join me after 2 hours. But no problem. Guys, you guys do know that if there's anything you missed and you need to keep on repeating the session, go on to the Awqaf website tonight or tomorrow, and you can replay this over and over and over again.
I've posted the link in the comments there. So if you are
Yes.
experiencing load shedding,
There we go.
that is the link to the video. It's always going to remain on our platform. It will go nowhere, and you can use this video as a revision as part of your final exam preparation. Over to you, Mr. K.
Just to answer Masia. Masia says, can we use the shortcut? No. The shortcut can only be used for the standard hyperbola, not for the hyperbola with the shift. So I hope that answers your question. I'll show you how it's done now. You can't use the shortcut here. You cannot, because that's only for the standard hyperbola. So you're going to start with y equals a over x minus p plus q. We're solving for a, p, and q. Now we know p and q. That's p, that's q. So that means we're going to go y equals a over x minus 2 plus 3. Are you following, Masia? Hit me up in the comments there. Masia, are you following now? Are you seeing what we're doing? Can you see why we can't use the shortcut now? Because we got asymptotes. We finally grew some asymptotes. Yes, Telani. Only standard A over X only. Telani should be our co-pilot. Right, now we got a point on the graph. Sorry, now we got, sorry, hey, I made a mistake. That's not P and Q. Yo, la hola, cardinal error. That's my P, that's my Q. That is just X and Y. It's just a random point on the graph. Sorry, my bad, mafos.
Yellow card.
Yellow card. Y6 equals A over X is 4 minus 2 plus 3. We're always solving for A. So 6 minus 3 equals A over 4 minus 2 is 2. 6 minus 3 is 3 equals A over 2. Times this side by 2. What I do on the right, I do on the left. A equals 6. So h of x, somebody said 24 over x minus 2 plus 3, you would be incorrect. H of x is equal to 6 over x minus 2 plus 3. So who gave me the incorrect answer there? Thanks for getting it wrong. So sometimes getting it wrong is your best teacher, am I right? Because now you will remember, you will not make this mistake in your exam. Right, here we go. Here we go, correct. Well done, guys, well done, well done. And that's how you get your answer. So if they ask you for what if they ask you for the equations of your asymptotes, and what would the equation of your asymptotes be? X is equal to 2, y is equal to 3. Those are the equations of your asymptotes. If they ask you for the domain of this graph, what is the domain of this graph? X greater than 2, because it's all your x values greater than 2. And what is the range of this specific graph? All your y values greater than 3. You could say 2 to positive infinity or 3 to positive infinity also. Both of them are correct. And we are done with the hyperbola with the shift in asymptotes. We're moving very fast. We're moving good. We're covering some good ground here, guys. We're now going to do the exponential. Now we're going on to, let's go. I hope you all took this down. Can we do the exponential? The last one, which is the exponential graph. Are you all ready? Thanks, Guguletu and Glovu. You're understanding nicely there. Amanda and Goveni, Karabo, Jennifer. Red. Me, I get red cards, bruh.
Yellow card.
Red cards. Yellow cards.
Yellow card. Take it easy on Mr.
Okay.
K today. It's Sunday.
Yeah. And we are fresh, Baba. We are fresh. I can run comrades to Cape Town and back.
In reverse.
Let's in reverse. Backwards. Backwards. Right. Put the heading the exponential. Now, this is also a very important graph. That's the last function you need to know. The exponential. Exponential. Now, the exponential, h of x or y equals a to the power x. Now, I'm going to give you a complete summary of this entire topic on this one screen. So if you learn the screen, you'll be sorted for your exams. So let's say you need to sketch y equals 2 to the power x, very popular one, or y equals a half to the power x. Right, put down your pens. That's your question. Here's your answer. Now that's a positive graph and that's a negative graph. So when your base is a fraction and x is positive, it's a negative. When your base is a whole number, it's a positive. Again, I know some of you use your table method on your calculator. I told you I don't use the calculator. I draw the table, x, y. I put 0, 1, 2, minus 1, minus 2. I always do that. Right? This is standard. Standard, Baba, standard for this graph. Now we substitute 2 to the power 0 is 1. Any base to the power 0 is 1, right, Zain? 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the minus 1. What's 2 to the negative 1? Half. 2 to the minus 2 is a quarter. Now we go to our graph. That's 0. Here's my first point, 0 and 1. 0 and 1. 1 and 2. 1, 1, 2. 2 and 4. Minus 1 half. Minus 2 and a quarter. And you join those dots going through 1. And making sure that it doesn't touch your x-axis. That's your x-axis. Take that one down. Take that one down. So I'll do the transformation. I'll give you the reflections of all the graphs. Strauss, we'll do the reflections of these graphs. Very easy. Standard set of laws. I'll show it to you. So that is the positive graph. Are you guys all following? Step number one. Step number one. Step number one. Draw your table. Put in your x values. 0, 1, 2, minus 1, minus 2. Step number two, substitute it into original. And step number three, draw your graph. So there we go, 3-step process. Are we okay with that, onliners? Are we good? Now let's do the negative graph. Transformation, we will do the reflections of this after this. Let me first show you how to sketch and how to find equations of these graphs. Right, now let's look at this one on that side. So, okay, we're done with this one, right? Let's put a line down our page. Now, this one here, that's your question. Here's your answer. The first thing you do, y equals a half is 2 to the minus 1 to the power x. So, y equals 2 to the minus x. That's why it's negative. Now, we draw our table again. Let's put x, y. Let's put 0, 1, 2, minus 1, minus 2. Let's sub it now into the original. 2 to the 0 is 1. 2 to the minus 1 is a half. 2 to the minus 2 is a quarter. 2 to the minus 1 is 2 to the plus 1, which is 2. 2 to the minus 2 is 2 to the plus 2, which is 4. We now go to our graph. That's 0. 0 and 1 is there. We know 0 and 1 is there. Minus 1 and 2. Minus 2 and 4. 1 and a half. 2 and a quarter. And we join these dots. So you can clearly see that a positive graph goes in that direction. And a positive graph is known as an increasing function. And a negative graph is known as a decreasing function. Right, take that down, take that down. We're almost at the end. We're almost at the end of functions. Let's go to StreamYard. We good, we good, we good. We are following. Give Gamer. Jacques.
Question.
So this here is only worth 3 marks. Ms. Kumalo. This is only 3 marks. Now I'm going to give you the summary of all the theory that's going to be asked about this. Right, look at the 2 graphs. Let's study the 2 graphs. Karabo. Let's still fresh Letlokonolo. Absolutely. This is only session 1. This is only phase 1 of our fight. Round 1. We've got about 3 or 4 rounds to go. Don't worry. Relax. We got this. Danko. Right, Bokang. Let's go. Let's go. I hope you took this down. Can I clear the frame? Give me a green light there. Have you taken all this down? Very important. Very, 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 very important for grade 11 and 12. You don't know this, you don't know functions. Okay. Can I clear? Can I clear the frame? Big Yankada, hello. How's it? Where are you hitting us from? Which part of South Africa? Or which part of the world? Okay, Messiah, I'm clearing the frame, guys. I'm clearing the frame. I'm clearing the frame. Now I need to give you the summary, the theory. Right, so let's clear the frame. Let's clear the frame. Here is the theory. Questions that they're going to ask you on the 2 graphs. So let's have a look at the 2 graphs again. That was your 1 graph, a positive graph, went through 0 and 1. And then this was your negative graph. and this came down in that direction, increasing, increasing, decreasing. 0 and 1. Right. That's your x-axis, that's your y-axis, that's 0. Right. There are a few questions they can ask you on this graph. Right, so both. What's common between? So here's your theory. Learn this. Right. All standard exponential graphs. Exponential graphs. These are standard exponential graphs. Number 1. What's common between the two here, guys? Look at it. What's the same? What's common between the two? They have only one y-intercept. 0 and 1. Both graphs only got one y-intercept, 0 and 1. Agreed? Why? Whenever x is 0, your y value, so y equals a to the x. Whenever x is 0, any base to the power 0 is always 1. Alhamdulillah. Number 2. Your x-axis for both graphs is your asymptote. They'll ask you, give the equation of the asymptote. And what's the equation of your x-axis? Y equals 0. A positive graph is known as an increasing function. A negative graph is known as a decreasing function. The domain for both graphs. Any x value will give you a y value. Any x value will give you a y value. So you can just say x is an element of real numbers, or you can say from minus infinity to positive infinity. The range of both graphs. Which y values? Remember, domain is x, range is y. Which y values? It's only your positive y values, not your negative. So y greater than 0. Y is an element of real numbers, or you can say from 0 to positive infinity. 0 round brackets, not square, because 0 is not included. And infinity is always with a round bracket. Take this down, learn this. Each one here is worth 1 mark or 2 marks each. This is the theory that they will ask you on these exponential graphs. We're almost at the end. Now we'll quickly do the reflections. We don't need to put in inverse lines here. Inverse is only for your grade 12. So don't stress about that, Strauss. Strauss, you stress too much. Oh, Azile Baloy, it's your birthday. Happy birthday. Yo. Imagine you doing maths on your birthday. Yo, what a present. The gift of math. Okay.
Are we going to sing
Vivian
happy
Khada, we
birthday?
love you too.
Are we going to sing happy birthday?
I think let's do it. Come.
Happy
Let's
birthday.
sing for them. Let's sing for them.
2,
Okay, so
3.
maybe it might not only be Vuchile's birthday, it might be everybody else's birthday. Many
And
people
Mother's
are
Day.
celebrating birthday on the Awqaf project. So let's all give them a come, guys. Happy birthday to you. Happy birthday to you. Happy birthday to you all. Happy birthday to you.
Hip, 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 hip. Hooray.
Hooray!
And another pip. Hooray. As you are.
Sang Zoman. Hey, all of a sudden, it's everybody's birthday today. Yeah, it's your birthday too, Khalil. Happy birthday, Amanda. It's everyone's birthday. Today is everybody. It's a happy day. Happy Math Day. Happy Math Day. Yo.
Happiness.
Right, so here we go. Right, I'm clearing the frame. Please, learners. Now, reflections. Reflections. Now, pay attention to reflections. They're going to ask you for reflections. So, let's say, guys, let's say they gave you, oh, Fazila, you are in the house. y is equal to 2 to the x, and they say, or h of x, which is y equal to 2 to the x, and they want the reflection. There are only 4 types of reflections. Number 1, reflection about the x-axis, reflection about the y-axis, reflection about the line y equal x, or reflection, the last one, reflection about the line y equal minus x. So these are the 4 reflections. Take this down. These are rules of reflection. Learn them well. You need to know it from now till the end of grade 12. Whenever they talk about reflection, whenever they talk about reflections, this is what they want.
Okay, so we're load shedding now.
Are you on load shedding now?
That's correct.
You still with me, Brew?
Yes, welcome to Mzanze.
That's
We have
it.
to work through the load shedding. I had to start up my generator there. I had to get Salma, my wife, to get some petrol. You know, that's what we need to do. No, but Mr. K.
The struggle is real.
No,
I'm telling
it's
you,
for
you
the
can
love
put a
of
South
math.
African in the Amazon. The South African will flip and survive, bruh. I'm
Yes.
telling you, those crocodiles will be scared of us.
But
We are
Mr. K,
resilient, Baba. We are resilient.
it's for the love of maths and for helping South Africa. It's for the love of it.
It's for survival.
There
Let's
we
not
go.
fool ourselves. We just need to survive.
There we
Right.
go.
The reflection about the x-axis, the y sign changes. Y sign changes. The reflection about the y-axis, x sign changes. Reflection about the line y equal x, the two swap over. But the signs don't change. And about the line y equal minus x, the two swap over. Write these rules down. They swap over. Both signs change. Now, guys, these are rules that you need to learn. Please, I've seen people, when they ask for reflections in the exam, I've seen learners actually try and move their paper and they're trying to do some hectic things in the exam. I don't know what you're doing. I look at them and I said, yo, bruh, what are you doing in that exam? You don't go and change your paper and try and reflect. No, you just learn these rules and apply these rules. Okay, don't come up with your own maths. It's done and dusted. Al-Khawarizmi came up with math, with algebra 1200 years ago. The rules of algorithm. Right. When you reflect something about the x-axis, the y sign changes. So what would your new reflection be? The y sign must change. So minus y equals 2 to the x. But in your final answer, can y ever be negative? No. So we divide by negative, we divide by negative. So when we reflect something about the x-axis, the y sign changes. So in your final answer, y equals, divide by minus, divide minus 2 to the x. And usually reflection is given by h of minus 1x. Right? Reflection about the y-axis, x sign changes. Y equals 2. We're looking at the original. 2 to the minus x. About the line y equal x, the 2 swap over. Your answer would be x equal 2 to the y. Just leave it like that. In grade 12, you'll convert this to a log. And y equal minus x, x equal 2 to the y, but both signs change. Minus x equals 2 to the minus y. Your final answer, x is equal to minus 2 to the minus y. There we go, guys. Those are your rules of reflection. we're on to the last part now, where I give you a graph and you need to find its equation for exponential. You need to learn this. Guys, time is moving so fast. It's already 10:15. We'll finish this up. We'll go for break. We'll come back and we'll start with trigonometry. We'll start with trigs immediately after the break. Guys, we are exactly 20 minutes away from break. We are 20 minutes away from break. So just to give you, I told you, you don't look at your watch today. I'll give you the time. I'll give you guys the time. You'll see how time will fly. Before you know it, today is over. And I'm enjoying it thoroughly being with all of you today. Right? Maybe Hasanain can hit us up with some stats of exactly how many login register. It doesn't mean exactly how many eyeballs on screen, but yeah, because some schools have got 50 learners, 100 learners behind one login. But as far as our login goes, maybe Hasanain can tell me what's our family looking like today. What's the Awqaf and Kway family looking like today for, I think we're over the 1,500 registration mark. Are we? Hasanain? You are muted. We can't hear you, Hasanain. We can't hear a word.
Let me just come on
There you
here
go.
so you can
I hear you now.
You can rest your vocal cords. So
Okay.
basically, tag Awqaf SA Maths in your social media updates. Our social media is hungry on Facebook, Instagram. Send us a pic of you logged on to the session in your living room, your classroom, your study, your bedroom. Send up some love. Normally we get some photos from some of our participants, and yesterday we had probably about like 3,500 YouTube views
Wow.
of yesterday's session. So
Wow,
not
wow, wow.
bad. And we expect more people to view the session during the course of the week. We know other learners are doing physics and open day and other tuition and functions. So maybe tonight they'll log on, or during the course of the week they will log on. So all that you need to do is log on to the Awqaf's website, awqafsa.org.za, and you can view the YouTube video. I have loaded today's video also. It is embedded on the Awqaf website. We will be showing you a video of that. So we do expect more viewership during the course of the day, as well as during the course of the week.
Can I take it away into the
Yes,
last 15 minutes?
go
Guys,
for it.
I know yesterday was crazy. So Cindelia says it's slow today. Time is a bit slow. No, guys, I'm just going a little bit at a more steady pace. I know yesterday bombarded many of you. Yesterday steamrolled you like you were hit by a bus. But relax. We got you. We got you. We're almost done. We're almost going into our first break. You'll see when I start with trigonometry and we start with Euclidean how. So, guys, you don't look at your time. You wait for me to give you the time. Before you know it, I'll say, right, 5 minutes to go, and the day is almost over. Okay, so love you guys lots for spending this entire weekend with us. I mean, it's not an easy thing, especially at this juncture, and especially for a learner who's 16 years old to sit in 2 days in a workshop. I know my wife went for a workshop yesterday on Hajj classes, and it was one entire day. She loved it, but at the end, she says, I don't think I can do one more day. But you guys know what's it all about. Okay, let's go back. Right, last one. We're now going to give you the graph. Please learn. You need to learn this. So come, let's give you a graph. Let's put that there. Let's give you that. Let's give you an exponential graph. Let's give you a graph that looks like this. Let me show you an exam style question. They call this point P. They call that point P X and Y. They give you another point here, point R, and they tell you that is 5 and 6. This is graph H. Question number 1. They want the coordinates of P. Question number 2. They want the equation of H. So they tell you H of X is equal to A to the power X. They want the equation of H. Question number 3. They want the equation, EQTN equation of the asymptote of H. Number 3. Is H of X increasing or decreasing? Number 5, they want the domain. And number 6, they want the range. Number 7, they want the equation of P of X if P of X is a reflection of H of X about the x-axis. And there we go. Here's a whole exam component. Master this. You sorted for the exams, guys. Thank you, Fuchila Manyangi. We appreciate you too. Right? In fact, we appreciate you more for being part of this program. Without you, the program can't go ahead. So yeah, we love you and we want to see top results. So here's an exam component. Here's an exam component, Gift Gamer. I hope you're enjoying today too, Gift Gamer. Right? We're almost done. We're almost into our first break. We're almost into our first break. We're going to answer these 7 questions. Let me give you some mark allocations. Let's give you some mark allocations. The coordinates of P, 1 mark. The equation of H, 3 marks. The equation of the asymptote, 1 mark. 1 mark. 1 mark. 1 mark. 3 marks. Total. 1 and 3, 4, 5, 6, 7, 8 and 3, 11 marks. And this is 11 marks for jam. Why? Because I did it with you already. I gave you the summary. The answers are there. Copy and paste. Yes, Bigyan, ask the question. I'm waiting. Bigyan Kadka.
Tafaddal.
Tafaddal. Yalla, Habibi.
Go ahead.
Ask
Mr.
the question.
Bigyan.
Ask.
Pose your question. Take us out of our misery.
Take us out. Right, so let's go. Let's jam this. Let's jam this while we wait for Bigyan to come through. Right, let's go. The coordinates of P. So we're answering the questions here on the side. Just going to erase that. Let's put our answers here on the side. Yeah, let's put our answers here. Right, answer to question number 1. The coordinates of P. What did I say? All standard exponential graph have only one y-intercept. So what is P's coordinates? 0 and 1. It's a no-brainer. Why? Because all standard exponential graphs, I told you according to your summary, have only one y-intercept, 0 and 1. Question number 2. The equation. So now you're going to go y equals a to the x. Now we choose x and y. 6 equals a to the 5. So a to the power 5 equals 6. So a is equal to the 5th root of 6. So h of x is equal to a to the x, the 5th root of 6 to the power x. Boom. There we go. We're solving for a. We are solving for a. We're solving for a. You almost free, brother. Give Gamer, you are almost free. You are 12 minutes away. Not even 12 minutes away from being free to having your lekker breakfast. What's your parents cooking up for you guys this morning? No shortcut here. Here because this is we're not multiplying. It's not x times y. Here we got to substitute x and y and make a the subject of the formula, Jacques. No shortcut here, Baba. No shortcut here. The equation of the asymptote. So we're done with the coordinates of P. We're done with that. Let's do question number 3. I'm going to put the answer here. The equation of the asymptote. What is your asymptote? Your x-axis. And what is the equation of your x-axis? Y equals 0. This is a positive graph. Is it increasing or decreasing? It's increasing. It's increasing. So we're done with question 1, done with question 2, done with question 3. There's your answer. Done with question 4. There's your answer. Let's do the domain and range. Come on, guys. Let's do the domain and range. We're almost there. We're almost there. You see the end line. I see the end in sight. Right. The domain. Any x value. So x is an element of real numbers. Any x value will give me a y value on the graph. The range, all your y values greater than 0. So y greater than 0, y is an element of real numbers. Why do we say element of real? It means it could be decimals or it could be fractions. That's why we say y is an element of reals. You have to say y is an element, because y is greater than 0. You don't want to put any restriction that y must be integers or y must be natural or whole. So you say y is an element because you don't want to exclude the decimals and the fraction. It can be a fraction, it can be half, can be quarter, can be anything. We're on to the last one. Do the last one on your own, the reflection one. Maths is your breakfast in the that's what I like to hear. We are eating maths for breakfast. We are eating. Ayanda, today's church session is all about maths. May the good Lord bless you. Let me touch your head. You will now get distinction. Ayanda Tladla. Do the last one. Maths is your breakfast. I'm loving that. Last one. Do the last one, and that takes us into break. Do the last one. In fact, we'll give you a little bit of an extended break also today. You are eating maguinya. With what? With mince. Or you eating it just hot, fresh out of the oil and butter. What are you eating there? Maguinyas. Cozy. You think we don't know maguinyas? I'll make you a maguinya. You'll first eat your fingers before you eat the maguinya. Is the domain, let me hear that question from Kway Maths. Is the domain for exponential graph the same throughout, or is it the same on the hyperbola? No, the domain for the hyperbola was different. The domain for the hyperbola was x was an element of real numbers, but x wasn't equal to 0. This is only for this for the standard exponential. Okay. LMFAO, mutton curry slops, maybe. Oh, it slaps. He claps. Mutton curry for breakfast and all. Hey, Owens are slamming mutton curry. I ate the nicest prawn bunny in my life, hasanain. In Durban, I won't even lie, in Springfield Park, the one, somebody told me to go to this one joint. Yeah, Allah, I never ate a prawn bunny like that in my life.
Do they make prawn bunnies?
My friend, shrimp bunny, red Durban curry with shrimp bunny. Hasanain. I can taste it. I close my eyes, I can taste it. Right, let's go on to the last one before we go for break.
Not fair, eh? You're actually making me hungry.
With the ice cold, that thing came out piping hot. They put it on the bunny like this. They poured the gravy over. They give you then a tall glass like this of ice, topped with ice and Coke. Sure, did I freak? And I had that for breakfast on a Sunday morning.
And a Gaviscon afterwards.
Huh?
And a Gaviscon thereafter.
No, not at all. It was amazing. I'm telling you, I had it about 2-3 years back, and I'm telling you, I've never ever had something as delicious and as divine as that. And you know, I'm a chef by trade.
Okay. I'm a doctor.
I'm a food connoisseur.
I'm a doctor. I've got lots of patience to deal with.
I get you there. You're becoming like Yasin Barnes.
A droog joke.
Right. So the reflection of h of x about the x-axis. So what was h of x? H of x was equal to the the fifth root of 6 or sixth root of 5? What was it? The fifth root of 6 to the power x. They want the reflection about the x-axis. So y sign must change. So that means minus p of x. They want it in the form p of x is equal to the fifth root of 6 to the power x. In your final answer, can p of x be negative? Reflection about the x-axis, your y sign changes. In my final answer, can p be negative? No. In your final answer, so therefore, here's your final answer. Therefore, p of x is equal to divide by minus 1, divide by minus 1, minus the fifth root of 6 to the power x. So reflection about the x-axis, just to show you what the graph would look like. Just to show you what the graph would look like. The graph would look like that. And what do you think this point is going to be? 0 and minus 1. Why? Because the y sign changes. And what do you think this point is going to be? R dash. It's going to be in the same line, so it will be 5. But the y sign changes. Minus 6. Doesn't it make sense? Kaboom! Everything fall into place. And there we go, there we go, there we go. Letlokonolo. I think you guys all deserve a nice round of applause, guys. Give yourselves a nice round of applause. We finished the whole of functions. Well done, Matlokonolo. Away. Right, it's 25 past 10. The time has just reached 25 past 10 on this beautiful Sunday morning. And after break, we start with trigs. We're going to start with reduction, identities, solving triangles, and then we're going to go into analytics and Euclidean. So guys, I hope you guys enjoy the break. No, just maths. I stick to my forte. This is my domain. My domain is math. Right. Assalamu alaikum. Have a lekker break, guys. Enjoy it. I see you guys 11 o'clock sharp. Enjoy your break. You got 35 minutes. Enjoy. Hasanain, assalamu alaikum, over and out.
Walaikum salam. Rest your vocal cords there, Mr. Kota, and enjoy your fresh air and your walk outside, stretch your legs.
We're coming back with a bigger bang. We're coming back with a bigger punch.
Aluta continua.
Yes, indeed. We're going to do trig ratios on a Cartesian plane also, my darling. Everything. Kaufela, man. Kaufela. We are mathsing today. Salam. Goodbye.
Okay, there we go. So that was Mr. Kota. We're just having a brief break and we'll resume after the break at about 11 o'clock. So there we go. This is what the program looks like. So we will resume at 11 o'clock. And any of you would like to view the video of today's session, you can do that. You can log on to the Awqaf's website, www.awqafsa.org.za. We have loaded the session on the Awqaf's website. This is the address, awqafsa.org.za, and I will show you a video of that. So while we are doing the break, let us play this video for you.
Quality education is a cornerstone of a thriving and prosperous society. However, the South African educational system is under strain, necessitating the work of the Educational Awqaf Fund to help ease the pressure. Our Matric Mathematics Upgrade project alone has already impacted the lives of over 40,000 matriculants. At the schools participating in our program, the pass rate increased from 70% to a remarkable 100%. For one student in particular, it was a life-changing experience.
So I've never reached that kind of height before. It was quite a milestone, and I believe that Awqaf has been quite instrumental in me reaching that milestone. And I also liked the spirit. Mr. Kota made sure that we're always engaged with the content. So for me, that's what made it a very positive.
with the very first word of the Holy Quran being revealed as read, educating our community is an act of faith. With your help, we can transform many more lives.
So that was Rory Sang. Rory Sang participated in our grade 12 workshop last year. We hosted one in preparation for the final examination, and Rory Sang participated in our competition. And our competition was there to award academic excellence and students who participated in the workshop and who performed well during their final exams. And Rory-san scored 100% in his mathematics, his final exams. He's currently studying at UCT, and this is a little video that he sent us, and I hope this serves as motivation to you. Let's take a listen.
Hello there, my name is Rorisa Makaila. I am in my first year of my undergraduate studies in actuarial science at the University of Cape Town. And as a result of hard work, dedication, support from friends, family, and teachers, and Awqaf's commitment to ensuring quality education for South Africans, I was able to obtain 100% in my matric examination for mathematics in 2022. So this was a culmination of very hard work that has been put in by myself and my teachers from earlier grades, more especially grade 11. I mean, this is a crucial part of your schooling career because universities offer provisional and conditional acceptances based on grade 11 results. And it's very heartbreaking to be willing to work hard towards your dreams in matric and not having anything to show for that with your grade 11 results. So it's very crucial that you work hard. And Awqaf SA has been greatly instrumental in me reaching my goals in matric.
We have another video that has been submitted by Rory Sang. So Rory Sang is a grade 12 learner of 2022, and he took part in Awqaf's workshop. He derived some benefit, and he was able to score 100%. And he also took part in Awqaf's competition that we normally run at the end of the year. So we'll also share some more information about that competition during the course of today. So here's another video submitted by Rory.
I believe that you can derive great value in attending the Awqaf SA mathematics workshops. I have gotten a lot of help from them, and I have a lot to show for it. So please just check that out and keep on working on your dreams and ensuring that you have a bright future for yourself. Lastly, I would like to thank Awqaf SA for their commitment in essentially building a better South Africa, because we know that in future careers that will be in great demand are those that involve science and mathematics, and by attending these workshops you'll be able to ensure that you participate in the future economy by working in these industries. So thank you very much to Awqaf SA and good luck on your examinations.
So there we go. That was an inspiring note from Rory Sang, and he's definitely one of the Awqaf SA Maths Workshop ambassadors. He continues to assist and inspire lots of learners, and we'll be playing this insert during lunchtime also, just to serve as motivation. This is a grade 11 workshop, and it's very crucial as grade 11 learners, school-going learners, that you lay a solid foundation in preparation for grade 12. And after grade 12, if you do well, then you may secure a good job, or you may have prospects of securing a bursary to study further or pursue your tertiary level of education. So let me bring this up. This is the Awqaf SA's website. So if you scroll to Awqaf's website, awqafsa.org.za, on the landing page of the site, let's make that a little bit bigger. There we go. So if you scroll onto the Awqaf SA's website, you have this little bit section that talks about Awqaf SA's maths workshops. Kindly be advised that this is a workshop for grade 10, grade 11, as well as grade 12. So if you want to register, you want to pass it on to your siblings, your family, people in your school, please do so. This is a section on the grade 11 math session that we've been doing. And what I have done for you, I have posted the videos on there. So if you click on the play button, that will play the session. So that is maths paper 1, and I have also included maths paper 2. So you can currently see that we are currently live. In the live video we are kind of viewing that. So all the videos will be placed on here. We will be also hosting a grade 12 workshop that will be taking place next week in Erasmia. If you know of anyone, you can tell them to go through to the venue. And then the last week we will be hosting a grade 10 workshop. So do let your friends and family know. So that's it for now. So we will take a break and we will see you after the break. So we will resume at 11 o'clock. So don't go anywhere. We're merely having a break time now. Welcome back, learners. Hope that you are rejuvenated and fresh. We will be sharing some more information about the competition. So all that you need to know is that the competition is only going to open in 2024 in January when the results become available for the grade 12 learners. This competition is open for grades 10 to 12. So that is something very important information. The other thing that I would love to also inform you is that, let me just zoom in. Is that if you have registered for this workshop and we do have your email details, if you're registered online, then all of you will receive an email communication when the competition does open. Because we're only going to open up registration for the competition in the new year, in January, once grade 12 learners have completed the exam. So what I'm going to do is, before we call on Mr. Kota, I'm just going to play this video. Rory-san could not join us yesterday because he has poor internet connection. He's currently on UCT. So what I'm going to do, I'm just going to play this video insert very quickly before Mr. Kota comes on. This is Rory-san. He entered our competition and he scored 100% in his grade 12 math.
Hello there, my name is Rory-san Makaila. I am in my first year of my undergraduate studies in actuarial science at the University of Cape Town. And as a result of hard work, dedication, support from friends, family, and teachers, and Awqaf's commitment to ensuring quality education for South Africans, I was able to obtain 100% in my matric examination for mathematics in 2022. So this was a culmination of very hard work that has been put in by myself and my teachers from earlier grades, more especially grade 11. I mean, this is a crucial part of your schooling career because universities offer provisional and conditional acceptances based on grade 11 results. And it's very heartbreaking to be willing to work hard towards your dreams in matric and not having anything to show for that with your grade 11 results. So it's very crucial that you work hard. And Awqaf SA has been greatly instrumental in me reaching my goals in matric.
So there we go, Mr. Kota. You just need to unmute yourself. So we are back, and we'll play a little bit more
And here
videos
we are.
of Rory-san. That was Rory-san. So we'll play more videos later on. He's got some other messages as to serve as a motivation to our learners. It's all yours. Take it away.
Welcome back, welcome back, welcome back. I hope you guys are energized as we are. How's the sound and picture there on your side, hasanain?
Lots of nur, lots of light. You illuminated after that break.
Lovely, lovely, lovely. Let me clear the frame here. We're starting with trigs. The first thing we need to know in trigs here is your overview. We need to know reduction. We need to know our special angles. We need to be able to reduce using our special angles. What are our special angles? 30 degrees, 45 degrees, and 60-degree angles. The second thing we need to know is how, so this is, the question will say simplify. Right, so put this down. We got reduction. Number 2, we got identities. And identities, the question will say prove. So that's identities. Where we got to prove left-hand side equal to the right-hand side. We got number 3, completing the diagram. Completing the diagram. Thank you so much. Completing the diagram. So they'll give you a diagram, Jazakallah so much. They'll give you a diagram that looks like that, and they'll give you a point P, -2 and 5, and they'll call that angle theta, and blah, 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 all the questions. So completing the diagram. And we also call it trig substitution, right? Trig substitution. And that's where we're going to stop for now. I'm not going to do the area rule, sine rule, cos rule. That you will do later on in tricks. And then your trig graphs. So inshallah, we'll complete all of this until our next break. Right, this year will take us, we're going to use this entire session to do tricks right through until 12:30. So it's 11:07. Synchronize your watches. It's 11:07. We're going to push through right through until 12:30. And so we've got about 1 hour, the better part of 1 hour, 20 minutes. Right?
Message.
This is with the aid of a diagram. With the aid of a diagram. Let's see let's see how's our, here we go. Everybody, we are all back.
I got a message for you, Mr. Kouter, your inbox.
Let's go there. Okay. Right, let's go. What we'll do, we're going to push now right through until 12:30. And let's get started, guys. Let's get started. Take it down. You all got it down. You need to know all of this. All this is coming in your exam. Let's go to the comments there. Let's go. Everybody is feeling great. Right. Let's start with the reduction. Now, let me tell you something. Reduction special angles. Right. Let's start. Put the heading there. Reduction. Right. I'm going to give you a summary of all the rules of reduction. We've got a 5-block rule. Right, the first is the Cartesian plane. That's the first block. The second set of rules is your negative angles. That's your second block. The third one is your anti-clockwise angle. So let's just put it like this. We're going to go anti-clockwise angle, your anti-clockwise angle, anti-clock angle. Then we're going to go, then we got our another block here. We got our square angles, an angle squared and angle squared. So we got our square angles. And then we got our angles greater than 360. Angles greater than 360. What do we do with all of them? So here we go, guys. We got 5 blocks. 5 blocks, and this will summarize your entire reduction. If you learn this, you're going to see when I start doing this. I don't want to start doing examples. I haven't shown you all the laws. You're going to fail. So these are the rules. These are the rules of the game, guys. Listen and listen carefully from now till the end of grade 12. Whatever other notes you have with reduction, you can use it as toilet paper. It's all here on one screen. I've summarized it for you. Cartesian plane. When we have a Cartesian plane, right? 90 plus, 90 minus, 270 plus, 270 minus. The name changes. Name changes. Cos to sine, sine to cos. So we avoid using that. The 180 plus, 180 minus, or 360 minus, we use. Because the name stays. Right, take this down. I'll explain this to you now. So if you had an angle, just to show you here, don't worry about that now. I'm just going to do it in red here on the side. So if you had sine 225 degrees and you had to reduce that, that would become sine. Are we going to say 180 plus 45 or 270 minus? I said use the 180 and 360. So it's going to be 180 plus 45. Don't say, now you know 180 plus is in that quadrant. You know that's 90, 180, 270, 360. 90 minus is there. 90 plus is here. 180 minus 90 plus is in the same quadrant. 180 plus 270 minus is in the same quadrant. 270 plus, because we're going anti-clockwise. and 360 minus is in the same quadrant. Right. So 180 plus. So now that falls away, your quadrant falls away. We're left with sine 45. 180 plus is in my third quadrant. We know sine in our third quadrant is negative. Yes or no? You know, A, all positive. Second quadrant, sine positive, everything else negative. Third quadrant, tan positive, everything else negative. Fourth quadrant, cos positive, everything else negative. So that is your Cartesian plane. That's how you would be reducing angles using the 180 and 360 and avoiding the 90 and 270. But if the 90 and 270 appears, we just change the name from sine to cos or cos to sine. Okay, so if you add sine 180 plus 30, or let's say 270 plus 30. Let's make it 270 just to show you. So say we had sine 270 plus 30. That would equal to sine 270. The name will change to cos 30. Be careful. Be careful. $270 plus is in this quadrant. Do we check where sine is positive or where cos is positive? You look at the original. Oh my word, what's happening here to my pen? My pen going crazy here. Right. 270 plus is in my fourth quadrant. We look at the original. What is sine in this quadrant? Sine is negative. And that will equal to minus cos 30 is root 3 over 2. And that's how we would do it. So that is your reduction. That is your first block on how to reduce. So I'm just going to erase this first one. You all know the Cartesian plane. That's your first block of rules. Let's go to your second block of rules. Your negative angles. Yes. Then it will become sine 270 over cos 270. Right? Wait, I'll show it to you now. We'll do this now. Let me get back here. What was this? This was negative angles. This was the anti-clockwise angle. Negative angles. So this was block number 1. Block number 2, negative angle. So if you had sine of a negative angle is equal to minus sine of that angle. Tan of a negative angle is equal to minus tan of that angle. Take the minus out. But cos of a negative angle is equal to positive cos of that angle. Cos of a negative changes to positive. Why? Negative angle is in your fourth, positive angle is in your first, cos is positive there, and cos is positive there. So cos of a negative angle is always positive. Okay. So that's your second block of rules. Are you guys all with me? Learn this. Learn this summary. Now we're going into an anti-clockwise angle. Let's go into the anti-clockwise angle there, onliners. So if I had sine x minus 270. Now you know sine 270 will change to cos x. Sine 270, name changes. Now watch here. Normally you have 270 minus x. Now it's x minus 270. So watch. Sine is in my first quadrant. We're moving 270 degrees anti-clockwise. So let's go from here. From there to there is 90. From there to there is 180. From there to there is 270. What is sine? Don't look at the converted. Look at the original. What is sine in this quadrant? Positive. Your answer is positive cos x. Are you with me? Let's do another example. What if I told you cos x minus 180. Now you know cos 180, it will stay cos x. We're going to move, cos is in this quadrant, fourth. We're going to move 180 anti-clockwise. So from here to here is 90, from there to there is 180. What is cos in this quadrant where it lands? Negative. And that's how you sort out the anti-clockwise angle. We use this, what I call the dial method. Learn it. It's easy. It's the best way to do the anti-clockwise angle. I'm teaching you rules, guys. I'm teaching you rules. Learn the rules. Now let's go on to the angle greater, a square angle. So if I told you sine squared 180 plus x. So sine 180 will remain sine squared x. Do I need to check whether it's positive or negative? No. Anything squared is always positive. Anything squared is always positive. Negative squared is positive. Positive squared is positive. So anything squared is always positive. So another example, if I told you cos squared 270 minus x. Now, because it's cos 270, it will change to sine squared x, and it will remain positive. Although 270 minus is in your third quadrant, cos is negative, don't worry, you got a squared. Anything squared is positive. Onliners, are you following me? Onliners, are you following me? These are the 5 block rules. If you can't do this, you can't do trigs. Full stop. Take it down. Letlokonolo, you got it. Pinde, Tyrese. Samke, thanks. Let me know if you're following. Hit us up in the comments. Thanks, Landa. Now, what happens if we have an angle greater than 360 degrees? What happens if we have an angle greater than 360 degrees? You know a circle is 360, so we got to minus 360 from it. So here we go, the last rule. Miley clues. We minus 360. So if I told you an angle like cos 480, so we minus 360. That is the same as saying cos 480 minus 360 is 120. Now we reduce the 120. So we say cos, right, Yusra, do I say 90 plus 30 or do I say 180 minus 60? Good. Why? I said avoid the 90 plus. I'm not saying you can't, but we don't want to change the name. So this is equal to cos 180 will remain cos 60. 180 minus is in my second quadrant. What is cos in my second quadrant? Negative. What is minus cos 60? Minus a half. And that's how you reduce it. So these are your 5 block rules of reduction, guys. Learn it and you are sorted. Nobody's going to show you these 5 block rules. If any teacher summarizes the whole thing and puts it into these 5 blocks, know that they learned it from us. These are my own study notes. I've summarized. This is my summary for you. Now you don't need to learn anything more about reduction. Everything is here on the screen. Memorize the screen. Now we're going to start with exam examples. Happiness, Mukhtar, happiness, Vuchila, Feziwe, Jaden, Tina, Livandra, Vuchile. Happiness. Happiness. Thank you, Kenneth. Thank you, Mukhtar. Right. There we go. Here we go. Here we go. So these are the rules. These are what you need to do. Let's get started. Are you ready? Can I clear the frame? Can I go straight into exam questions? And these are worth 5 to 7 marks. Thank you, Calvandre. Dolly. Calvandre. Let's go. I'm clearing the frame, guys. I'm clearing the frame. So let's clear the frame. Right, simplify the following. Here we go. Sine 120, let's go. Simplify the following. Simplify. Right, sine 120 degrees times tan squared 330 all over cos 135 times sine 225. Right, let's do it together. Let's do it together. So sine 120, 180 minus 60. Tan squared, it's going to be tan squared. 330 is 360 minus 30. All over cos 135, 180 minus 45, your special angles. Sine 225, 180 plus 45. Now let's reduce. I put a tick there. Hit me up in the comments. Are you all following that? You all know what I did. Now we need to drop the quadrants and reduce. We need to drop the quadrants and we need to reduce or keep the name or change the name, whatever the question, whatever the reduction tells us. Thanks, Tyrese. So let's go. Sine 180, the name will stay sine 60. 180 minus is in my second quadrant, sine is positive. Times tan 360 will remain tan squared 30. Do I need to check whether it's positive or negative? No. Anything squared is always positive. Cos 180 will remain cos 45. 180 minus is in my second quadrant. What is cos in my second quadrant? Negative. Remember, all positive. Only sine is positive. That means cos is negative. Only tan positive, only cos positive in fourth. Times sine 180 will remain sine 45. 180 plus is in my third quadrant. What is sine in my third quadrant? Negative. I'm going to put a negative, I'll put a tick there. You all following me there? Are you all following me there? You know what I did? We dropped the quadrants. We dropped the quadrants. Now we need to convert to our special angles. Now here you can cheat. You can use your special, you can use your calculators, but you can't use decimals. So let's go. Let's reduce. Negative times the negative is a positive. So that's gone. Sine 60 we know is root 3 over 2. Tan 30. What is tan 30? Root 3 over 3. Squared. Over. Cos 45 is root 2 over 2. Sine 45 is root 2 over 2. Or 1 over root 2. Same thing. Now let's say that is root 3 over 2 times. Root 3 squared is 3 over. 3 squared is 9. Divided by. Root 2 times root 2 is 2 over 4, which is a half. Okay. Root 3 squared is 3. 3 squared is 9. So we're going to multiply this by 2 over 1. We're going to multiply that by 2 over 1. That will be gone. 2 and 2 will cancel. Your answer is 3 root 3 over 9. Let's double check. Sine 60, root 3 over 2. Tan 30, root 3 over 3 squared. Cos 45, sine 45. That's correct. We're going to get rid of the half. We multiply it by its reciprocal. What we do to the denominator, we do to the numerator. Root 3 times 3 is 3 root 3. 1 times 9 is 9. 3 goes into 3 once. 3 goes into 9 3 times. Your final answer, root 3 over 3. And that's your final answer. That's your final answer. Onliners. Onliners, are we good? Are we good? Well done, well done, well done, well done, well done, well done. Do you guys want one more to do like this? Do you do one more where I'm going to include a negative angle in it? I'm giving you one more in terms of angles, then I'm going to give you a reduction just in terms of x. So we'll do 2 examples. Your calculator, you just plug it in, your special angles, it will give it to you in third sign. Right, as long as you're not using decimals, guys, as long as you're not using decimals. Right, so let's go. I don't know what's going on here. What happened there to my board? What happened to my board? Whoa. And my tabs all disappeared. Got a bit of a glitch here. Do the StreamYard.com. There we go. Okay, we there? We still there? Hasanain, we good? Can you hear me? It's 5 marks, guys. 5 marks.
Loud and clear.
Okay, I don't know what happened here. Okay, wait. Is my board still showing?
That's correct. We can see your board. What seems to be the issue or the
Okay,
challenge?
give me a second. Give me a second. Give me a second. Let me go again there. I don't seem to be getting my Google Meet board. I don't know. My board disappeared, guys.
Okay, so we can see it. So basically,
You
what
can
you
see my board, right?
yes,
You
that's
can
correct.
see my
So
board. Let me go to present. No, but it's still saying presenting, but I can't find my tab on the top.
No
I don't know what
problem.
happened there. Oh, okay, view tab. I think it's there. Okay, are you seeing it?
We can see it, but we just need for you to.
Okay. There we go. Right.
Houston, we are back.
We back, and we better than before. Right. Sine -10. Sine 240. Do this one on your own. Don't wait for me to start. Tan squared 315 times tan squared 315 all over sine -225. Cos 440. Can you see what's happening? All our 5 block rules are being asked. Cos 135. 6 marks. Simplify without the use of a calculator. Kill it. Kill it. Let's check. No, the question, MK Mashaba, the question said tan squared 315. It's in the question. Anything squared is positive. So, like I said, Mr. Mashaba, even if it's in the 4th quadrant, the minute it's squared, anything squared is positive. There we go. Thank you, Vuchila. You're listening to me. You actually repeating my words. Anything squared is positive. That's correct. Right. Let's do this one. I know we're moving. Give me a second. Let's go back to Jamboard. Let's toggle between that. This is equal to sine of a negative angle minus sine 10. Sine 240, sine 180 plus 60. We need to move fast, guys. Tan squared 315 is tan squared 360 minus 45. All over. Minus sine 225. And 225 is 180 plus 45. Cos 440 is cos, we're going to minus 360. So that's cos 80. So 440 minus 360 is 80. And now I'm going to say 90 minus 10. Why am I using 90? Because I got a 10 on the top, I got a 10 in the bottom. In the next step, they're going to cancel each other out. Times cos 135 is 180 minus 45. I hope you all got that. I hope you all got that. I'm going to give you guys a couple of minutes. Let's see our comments coming in. Did you guys get that? Are you understanding? I know you might have made, some of you might have made some silly errors. Thank you, Miley. Miley Clues got it. Mulisa got it. Tabo, January, you know we are in May. Please make sure you get it right. Tanyani. Well done, well done, well done, well done, well done. I'll give you guys 2 more minutes. Sindile didn't get it, but I hope you know where you made your mistakes. Well done, Letlo Konolo. Good, 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 good. Let's go. Let's reduce. Come, let's do it together. Let's do it together. Watch here. Let's reduce. Minus sine 10 times. Sine 180 plus 60 is sine 60. 180 plus is in my third quadrant. Sine is negative. Tan squared 360 is tan squared 45. Do I need to check whether it's positive or negative? No. Positive. Sine 180 will remain sine 45. 180 plus is in my third quadrant. Sine is negative. Negative times that negative makes it a positive. Cos 90 will change to sine 10. 90 and 270 changes the name from sine to cos or cos to sine, co-function. 90 minus is in my first. There's it. 90 minus is in my first quadrant. Cos is positive. Times cos 180 will remain cos 45. That falls away. 180 minus is in my second quadrant. Cos is negative. Now let's check. We got 1, 2, 3 negative signs will make it negative. Odd number of signs being multiplied or divided is negative. Even number of signs will make it positive. Sine 10, sine 10. Sine 60. So all our signs are gone there. Sine 60 is root 3 over 2. Tan 45 is 1. 1 squared is 1. Divided by sine 45. Sine 45 is root 2 over 2. Or 1 over root 2. Multiplied by cos 45 is also 1 over root 2. That's minus root 3 over 2 divided by 1 times 1 is 1 over root 2 times root 2 is 2 times 2 times 2. Your answer is minus root 3. That's your final answer. There we go. There we go. There we go. I'm going to give you one more. I'm going to give you one more. Did you all get it right? Did you all get it right? Yay! Well done. Well done. Well done. We're using the 5-block rule. We're using the 5-block rule. Well done, Linda. Well done, Poncho. Scroll up. I can't scroll anymore. There's my Jamboard. I've got full screen here. Let me try something. Let me try something.
I've removed the banner. The banner was in the way.
You removed the banner.
Apologies.
Okay. Is that better, guys? Is that better? Sisa Dolly. You're understanding, right? Here's the last one for everyone. Here's the last one for everyone. Let's clear the frame. Okay, those of you who are still writing, that's fine. Let's put the last one down. Give me a second. Let's go simplify. Simplify. Give me a second. Cos squared 90 minus a. Cos squared, let's make it x. 90 minus x. Cos minus 180 minus x. Interesting situation here. Times 10. 360 minus x. All over. Sine 360 plus x. Multiplied by sine minus x. For 6 marks, simplify that. Right? I'll scroll it up again. Those of you who want to start, you can start. That's the last one we're doing. Then we're going to do using diagrams. Oh, you know what? In our trig, in that trig stuff that I gave you, you know, the overview, I forgot to put in a general solution. Solve for x using general solution. So guys, just go back to your trigs where I put reduction identities and I gave you all the topics. Put there, we have to add on the general solution. Now we don't have much time. It's already 20 to 12. Half the day is almost gone. Right, take it down, take it down, take it down, take it down. Let me clear all of this first. That's out. Reduce that. Reduce that. And I will give you a couple of minutes to finish that. Let's 6 divided by 2, you got 3 minutes. 3 minutes, guys. 3 minutes to sort this one out. Let me just erase that at the bottom as well. And that is gone. Let's go back. And let's reduce. Right. You know, there's your square angle. That's your negative, that's your anti-clockwise negative angle. Ooh, I'll show you what to do there. Reduction, reduction, negative angle. The problem, I think the big challenge will come in here. What do you guys do with that? That's the question. I'll show you what to do. Many of you are going to get bombed out here with the second part. Okay, let's do it. Let me do it with you. Cos squared 90. Cos 90 will change to sine squared x. 90 minus is in my first quadrant. Everything's positive. Now watch what we do. Cos, when you got this, you make it a negative angle in the bracket. So it's minus into 180 plus x. Like that. Tan 360 will change to, will remain tan x. 360 minus is in my fourth quadrant. Tan is negative. Sine 360 will be sine x. 360 plus is in my first quadrant. Sine is positive. And sine of a negative angle is minus sine of that angle. Now we need to sort that out. So watch what we do. Sine squared x times cos of a negative angle. Remember I told you cos of a negative angle is positive cos of that angle. So that negative falls away. So that negative falls away. So you're left with cos 180 plus x times minus tan x is sin x over cos x. That's over 1. That's over 1. All over. Positive times negative is negative. Sine times sine is sine squared x. There we go. Take that one down. Take that one down. Take that step. Very, very important step. Crucial step. Critical step. You mess it up there, you gone. Let's see. Letlokonolo says she got sin x. Let's check what the boss is. Letlokonolo. Somebody got an answer of 1. Somebody got an answer of sin x. Let's see who's right. I don't work from memos. So I don't even know what the answer to this is. We're working it out together. This is equal to sine squared x over 1 multiply. Cos 180 will remain cos x. But 180 plus is in my third quadrant. Cos is negative. Times minus sine x over cos x. Divided by minus sine squared x. This is equal to negative 1, 2, 3 negatives. We'll make it negative. So far, it seems like both of you are wrong. One got the answer is 1. The other one got the answer is sin x. Both of you are wrong. There's a negative there. Cos x, cos x. sine squared x, sine squared x. We only left with sine x. That's your answer, guys. That's your final answer. Two marks for each step. Akil, 2 marks for each step. 6 marks. 2, 4, 6. So your answer is negative sine x, guys. Now, I hope you know where you went wrong. Letlokonolo, I hope you know where you went wrong. It's not positive sine x. You missed out the negative. Who was that? Sagzoman. Klauleko. Yeah. What happened to the negative? 3 negatives. 1 negative, 2 negatives, 3 negatives make the whole thing negative. Negative times negative is a positive, divided by a negative is a negative. Are you all following? Well done, Livandre. Well done, well done, well done. Right. Let's now do okay. Then A. Okay. I'm going to give you a diagram now. I'm giving you a diagram. Right, so let's go there. Let's go there. Let's give you that. I tell you this is the point P. That's O. That's your x-axis. That's your y-axis. That's angle theta. I tell you P's coordinates is -5 and -5 on my x and -6 on my y. Right. With the aid of a diagram, answer the following. Number 1, I want sine theta. Number 2, I want 2 cos theta minus sine theta. Number 3, find the value of theta. Using this diagram. So take this down, guys. We're doing trig diagrams. You're definitely going to see it in your exam. In fact, your diagram is your first question in trigs. Then you'll get a reduction, you'll get an identity, you'll get a general solution. It's easy, man. Full marks. Right, let's put mark allocation. Let's put mark allocation. That will give you 2 marks. That I'll give you 4 marks. This one I'll give you 4 marks. 4 and 4 is 8 and 2, 10 marks. There we go. Are you guys following? Where's the 17? Righto. Mutari, where was the 17 in the last problem? 90 minus, what was it? X. It was X, not 17. Where you got 17 from? Right, let's do this. Let's do this together. Right, you always drop your 90 degrees, not on your Y, you drop it on your X axis. That's your X, that's your Y. So X, there's your 90 degrees. Your X is -5, your Y is -6. Now we use Pythagoras. We want the hypotenuse. So h squared is equal to -5 squared plus -6 squared. H squared is equal to 25 plus 36. H squared is equal to 61. H is equal to the square root of 61. So H is the square root of 61. So we use Pythagoras. We use Pythagoras to complete the diagram. Now we all know we have to use SOHCAHTOA. Remember, whenever we have a 90-degree triangle, we use SOHCAHTOA. What do we use? SOHCAHTOA. Sine, opposite over hypotenuse. Cos, adjacent over hypotenuse. Tan, opposite over adjacent. So let's answer our questions. Question number 1, sine theta. Sine theta is opposite over hypotenuse. SOHCAHTOA. So what's your opposite? What's your hypotenuse? Hey, what's going on with my nibs? My pen's going crazy here. Right, so sine, that's your opposite, that's your hypotenuse, that's your adjacent. So opposite over hypotenuse. You guys, I think my pen is giving up. I think my pen is giving up. Let's go back again. Don't irritate me now, Mr. Pen.
Gonna have to use your finger. Gonna have to use your finger, Mr. Kota.
Ooh, that's a problem. Opposite over hypotenuse is minus 6 over root 61. The answer to question number 2. 2 cos theta minus sine theta. That's 2. What is cos? Adjacent over hypotenuse. Minus sine is opposite over hypotenuse. So that's 2. Adjacent over hypotenuse is minus 5 over root 61 minus opposite over minus 6 over root 61. So 2 times minus 5 is minus 10. Negative times negative is a positive 6 over root 61. And that would give me minus 4 over root 61. And that's your final answer. Easy. We're just substituting from the diagram into our question. And then we had here find theta. Find the value of theta for 4 marks. That's why it was worth 4 marks. Now let's do the answer to question number 3. Let's do the answer to question number 3. Find theta. So we can use sine cos. I'm going to use tan because it's 6 over 5. It's easy. So I'm going to say tan theta is equal to opposite over adjacent. You could use sine or cos, but I don't want to use a third sign. So tan theta is equal to opposite over adjacent, 6 over 5. So what is theta equal to? Shift tan. Now we use the shift key on our calculator. Shift tan, 6 over 5. 50, 19, 50, 2 degrees. 50, 2. So this is this angle here, 50, 2. But theta, what they told us in the diagram is this entire angle here. So it's 180. Therefore, in the diagram, theta is equal to 180 plus 50, 2, which is equal to 230, 2 degrees. Because this angle here is a reflex angle. It's 180 plus. Are you all following me? Onliners, are we okay, guys? Yes, 50, 19, let lokonolo. Let lokonolo, something tells me you're going to be one of our 100%ers at the end of the year, and I'm hoping so. Say amen. Say amen.
Another Rory song. Amen.
Another Rory.
Amen.
Well done, Masia. Well done, Sipa. Well done, Tandiwe, and everybody else.
You on a roll, Mr. Kota?
We on a roll. We on a roll. We on a roll. Right. I'm now going to... So we all know how to do this with the aid of a diagram. Let's do one where we got to draw a diagram. Right? Pay attention. Pay attention. We're going to do one more of this trig substitution. Right. Pay attention. You've got it. You've taken it down. Can I clear the... Got it. Thank you. I am clearing the Jamboard. Let's clear the frame. You all got it, guys? You all took it down here in-house? All right. Watch the, let's see if you guys can do this one. Now, what if they don't give you a diagram? You are requested to draw a diagram. If root 53 sine theta minus 7 equals 0, and theta is an element of 90 to 360 degrees, find, with the aid of a sketch, find the value of 2 cos squared theta plus 3 sine squared theta, for 5 marks. Go for it. You need to draw the diagram. That's your answer. Right. Now, whenever you are required to draw a diagram, come I teach you a little acronym. Use the method SCRAP. Use the method SCRAP. S, put this into standard form. Standard form. Right? Put it into standard form, and S for SOHCAHTOA. Number 2, C for Cartesian plane. Draw your Cartesian plane. R, look at your restriction to draw your triangle. A, just for and P is for Pythag. So whenever you see this, just use SCRAP. You'll get your answer. Right? So whenever you see this, you use SCRAP. So for reduction, we had the 5-block rule. For this, where we need to draw a triangle, what do we use? SCRAP. I will give you guys 5 minutes. I'm taking a bathroom break for 5 minutes. I'm giving you 5 minutes to do this. Hasanain, you'll keep everybody going for 5 minutes.
Please come back, Mr. Kouter. Come back.
I'll be back. I'll be back. I'll be back.
Vas jou hande. Okay, there we go. Mr. Kouter is on a relief break. Bless him. Yeah, Mida, thank you for your comments. We appreciate all of the participants that's on the workshop, the energy that you're giving us, and your hard work that you're putting into the session, and your feedback and your validation definitely gives us some encouragement, especially Mr. Kouter. Thank you, Miley. We've been doing this online workshop since 2021, and every year and with every workshop, we hope to improve the quality of the class, thus having some sort of a contributing factor to your success. Linda, we used to do school tours in 2016. That's how we started off the project. We used to go to Soweto, Cape Town, and KwaZulu-Natal. We do sometimes do school tours. We will be doing one next week. And we're back. I think I just dropped off there for the moment. As I was saying, that we will be hosting a workshop next week. It's a grade 12 workshop in Pretoria at the Al Ghazali Hall. So if you know anyone in grade 12, you can come through. So Mr. Kota will join us shortly. I can see by the comments, I can't put it up on the screen. Mr. Kota definitely had to go and relieve himself. So while we're waiting for Mr. Kota, what we can do is let's play another video from Rory Sang, our hero.
I believe that you can derive great value in attending the Awqaf SA mathematics workshops. I have gotten a lot of help from them, and I have a lot to show for it. So please just check that out and keep on working on your dreams and ensuring that you have a bright future for yourself. Lastly, I would like to thank Awqaf SA for their commitment in essentially building a better South Africa, because we know that in future careers that will be in great demand are those that involve science and mathematics, and by attending these workshops you'll be able to ensure that you participate in the future economy by working in these industries. So thank you very much to Awqaf SA, and good luck on your examinations.
So there we go. That's the second video from Rory Sang. He scored 100% in mathematics last year during our grade 12 workshop, and he's currently studying actuarial science. So let that be as some sort of an inspiration to those that are wanting to do well academically, and also if you want to pursue your education at a university institution. So I wanted to find out from the okay, there we go. The man is back in the building. Mr. K. Oh, you want to eat something? Okay, Mr. K, eat something, have something nice while, but we can't hear you. You're on mute.
Let me unmute myself.
No,
I'm
come
sick and
back.
hungry.
No, but why don't
Yo.
you have your sandwich? Have your sandwich while I
Okay.
speak to the learners, because you know why? You also need to replenish your nutrition and
This is rough.
yeah, no, definitely. The speculation was rife of where you went to. You said that you
What
went
they say?
to
What they say?
the bush to take. But anyway, we see that you had to grab a sawmi to replenish yourself. But look,
I'm dying.
a speech,
Bring my coke, please.
expediating some of the questions or
Hey,
some of
Kasam. See, Tyrese. Lady shirt.
these guys are rotten. I don't know. I couldn't cover you there, Mr. K.
No, you can't cover me. Let's go. Let's go. We're back in. Right. So let's do standard form SOHCAHTOA. So let's put it into standard form. So we're going to have root 53 sine theta is equal to, we take that 7 on the other side, then sine theta is equal to 7 over root 53. That's standard form. SOHCAHTOA side is opposite over hypotenuse. Cartesian plane, let's draw the Cartesian plane. Right. It's from 90 to 360. 90, 180 to 70, 360. So that means, according to my restriction, it has to be there, or there. But where is sign positive in these three? Second quadrant. There we go. It has to be drawn in because that is where sign is positive, and that is, it fulfills our restriction. So we're done with that, we're done with that, we're done with that. A is just for and now we use Pythagoras. So let's drop our 90 degrees. That is angle theta. Sine opposite over hypotenuse. So now let us use Pythagoras, guys. So we got root 53 squared. The square on the hypotenuse is equal to 7 squared plus x squared. We call that x. We don't know it. We're going to find it out. 53 is equal to 49 plus x squared. 53 minus 49 is equal to x squared. I'm doing Pythagoras. So x squared is equal to 4. X is equal to plus or minus 2. But remember, it's to the left. So it has to be minus 2. It can't be plus 2. X is equal to minus 2. Did you all get that? Onliners, did you all get that? Did you all draw the diagram correctly? If you drew the diagram incorrectly, you are in trouble. Nokwazi, the break is at 12:30. It's 12:05. It's 12:05. You see your mistake, boy. Choko van Wyk. Yebo. Wasim Hans. Hey, Wasim, how you, bro? Where? Right, let's go. Back to Jamboard. Now we say fine, 2 cos squared. So this was only to complete the diagram. Now we get our answer. Therefore, 2 cos squared theta plus 3 sine squared theta is equal to 2 into adjacent over hypotenuse squared plus 3 into opposite over hypotenuse squared. So 2 into adjacent over hypotenuse minus 2 over root 53 plus 3 into 7 over root 53 squared. Now, that's 2 into minus 2 squared is 4. Root 53 squared is 53. Plus 3 into 7 squared is 49. Over root 53 squared is 53. Moving over to the side, 2 times 4 is 8 over 53. Plus 49 plus 3 is 52. Am I right? Over 53. My final answer, 8 plus 52. Oh yeah, the 3. What am I doing? La hawla wa la quwwata. Astaghfirullah. That's 147. Thank you. Yo. 147. Right. So 147 plus 8. What? Your final answer. Somebody did say that. 155 over 53. Let's see who said that. Somebody is a boss here. Somebody is a boss. You got it right. Well done, well done, well done. Let me go back to StreamYard. Somebody did say that. Messiah, like a boss, Messiah. Like a boss. Well done. Do not convert it. Somebody used, somebody said 2,94. Kenneth, no, do not use, without the use of a calculator, so no decimals. You leave your answer in fraction form. Well done, Linda. Well done, Linda. Well done, Messiah. And well done, everybody else. Okay, now we're going into, now watch the next one. They tell you if sine 20 equals k, find the following in terms of k. Westbury got it. Alia Khan, well done. Amanda Ngoveni, well done. Kudos to you. Sharp. Moja, Dolly, Nga. Kway. You Kway. You are smart, Vuchila. Don't feel smart. Be smart. No decimal, Kenneth. No decimal. Well done, Tyrese. Okay, guys. Let's go back to Jamboard. I hope you all took it down. I'm clearing the frame. check the next one out. They love the next style of question. Till grade 12. Guys, this is 11 and 12. This is grade 11. All this work we're doing is for this year and next year.
Mr. K, when are we going to see some of your in-person participants? You didn't introduce them to us.
Yes, okay. We're going to do that now. Okay, come here. Let's come and say hello to everybody. Come, guys. Come line up here. Come line up here. No, that was yesterday. Today we got new ones also. Yes. Just come say hello. Just say hi, guys. This is Romana. Hello, Romana. Come say hello to everybody there. Say hello. You enjoying it, Romana? There's Zayed. Come through. Zain. The hunk. There we go. There's Zain. And there's you, Saira. Guys. Okay, let's get back to work. Right. If sine 20 equals k and k is greater than 90 but less than 360, find cos 20. Cos 20. Cos 200. Sine minus 20 in terms of k. Mark allocation, 2 marks, 3 marks, 2 marks, 7 marks on this question. We do the same thing. We need to draw a triangle, so we use scrap. SCRAP. I hope you remember scrap. Standard form, Sohcahtoa, Cartesian plane restriction, and Pythagoras. Yes, she's alive. She's alive. Yeah, it goes with me. Answer. So standard form, Sohcahtoa, sine 20 equals k over 1. Sohcahtoa, opposite over hypotenuse. Boom. Cartesian plane. Boom. Restriction. Greater than 90, less than 360 means can be there, or there. Where is sine positive? Second quadrant. So in this question again, second quadrant. Boom, boom. 20 degrees is there. Opposite over hypotenuse, k over 1. So let's do that. Let's do this. K over 1. So we need x. So that means 1 squared is equal to x squared plus k squared, Pythagoras. So 1 minus k squared is equal to x squared. That's a k. So x squared is equal to 1 minus k squared. X is equal to plus or minus the square root of 1 minus k squared. But it's to the negative, so it's minus the square root of 1 minus k squared. Now let's answer the question. Question number 1, cos 20 is equal to adjacent over hypotenuse. Adjacent over hypotenuse minus the square root of 1 minus k squared over 1, which is equal to minus the square root of 1 minus k squared. That's your final answer. You got yourself 2 marks. Learn. I beg you, learn. 2 years, grade 11 and 12. Number 2. Hasanain, when we're having a live event, so I can see all, so that everybody, if we have a live event, guys, at one big auditorium, will you guys all come through for it? Grade 11s. And me and Hasanain rock the show. days.
Arm wrestle, or a Street Fighter game contest
Street
slash
Fighter game
match.
competition. We have some. They'll come. Namira, you'll come. A live event. Mikenzo Chauke is giving us trophies there.
Yes.
Hint, hint, nudge, nudge, Hasanain. Talk to Awqaf,
Yes,
bruh. We want a live event. We will definitely, even if you have to come from across the country, will you come for a live event? Maybe we have it in a movie house.
Yes. But look, we are going to be beaming from Al Ghazali next week, but that's for grade 12, right?
That's for grade 12. But I want a smart event, man. I want something in the auditorium. I want something in the movie house. We want something at, we're going to have something grand. A blast event. End of the year. Inshallah. You guys all book. You all come. You fly down. You drive down. You book. Whatever. You come for 2 days. And we dollar maths. Anybody ask you where you're going? You're packing your bags, backpack. I'm going for math, bruh. I know. Yo. Right. Cos 200 is cos. Which angle? No. You're substituting it. 20 degrees is your reference angle. I know you'll come, Leanne. I know Bokang, you'll come. Hasanain, are you listening, bro? So cos 200 is 180 plus 20. We want the 20 degrees in. So that cos 180 reduction, cos 20, 180 plus is in my third quadrant, cos is negative. Now, that's minus, and we got cos 20 in the previous one, minus the square root of 1 minus k squared. So negative times negative is a positive. Your answer is just the square root of 1 minus k squared. That's your final answer. Because you got to give your answer in terms of k. You got to give your answer in terms of k. Hasanain, end of the year, it's live. We're going to do it in a proper venue.
Are you going to sing for us?
Of course.
We have to do something. We need to have a nice, besides the rocket launch, we need to have some sort of a stick for an online thing. For the in-person.
Want me to sing?
Event. Yeah, I know. You see, I got a new mic, a Rode mic here. You might just damage.
I can rap for you in Afrikaans, my bro.
No. Please, no.
Please, man.
Not yet,
Please,
man. It's too early in the day, man. I'm still cheery and happy.
Please, man. Let me rap for you in Afrikaans, man.
No, I've heard it before, man. It's
no, man. No, you heard it.
No, man.
Kykie, my bro, al die dinge moet sy los van die week se geld en hy blik se kos en as ek kyk is, dan kry ek mooi 'n brasse om te idle om 'n hoek om 'n pyp te roep, maar die dinge sal nie bekkie, dit maak jou ousie pekkie so uitgedraai en jou slaat jou teen die bekkie. Jou ma, jou pa, hulle almal kry swaar van sonder 'n job is als die mekaar. Die rent, die lig, die water gaan op. Ek sê my bro, vergeet van die dop moet nie mop. Voor die ding doen alles en jy moet om geld in te bring. Jy is 'n total disgrace. Jy maak hom af wie grys. Hy slaat jou met 'n face, miskien raak jy wys away hoor.
Whoa, Mr. Kouter, smoking hot.
Ek slaat jou binne my
house. In the house, in true effect. Oh my word. There goes our channel.
Hey, that's Bali. Away, Bali, what kind, Lani?
There goes our program.
Ghetto math, this is ghetto, underground math. We do it in a parking lot. We do math in underground. We make donuts in math.
It's too much that kakamas that you're watching.
Right, number 3, sine minus 20. Sine minus 20, that's a negative angle, minus sine 20, which is equal to minus k. Because sine 20 is k, so we want minus sine 20, and that is minus k. Hey, let's say, host a live event, Ma'am Shaidung will organize. Poncho, Ma'am Shaidung, are you there? Where, ma'am? You going to organize it? Hey, you don't understand Afrikaans. Jy moet wys raak, Sani. Hi, my Mela, you tell me I'm those ones that attend idols, that can't sing, that can't rap. Well done, Jaden. Go, Mr. K. Mr. K, he's our man. He can do it. No one can. Go, K. All right. Okay. Next one. We're done here. You've all taken it down. Yeah, just a little bit of comedic relief through math. You know, math can make you lose your bonkers. Innocent, coming soon, Baba. Coming soon. In the work, it's called work in progress. Right, let's do an identity. It's 20 past 12. Time flies when we're in a coma. When we're having fun. We're in a math coma here, bruh. Right, let's go. Identities. Now we need to prove left-hand side equal to right-hand side. I'm going to teach you a new acronym. Right? Identities. Now, identities mean identical. We need to prove that left-hand side is equal to right-hand side. Right. So we use 2 steps. Ali. Who does identities? Ali does identities. What does AL stand for? Algebra. And then look for your identity. So Ali does identities. What are your identities? You know sine squared theta plus cos squared theta equals 1. You know tan theta equals sine theta over cos theta. And you know that tan squared theta is sine squared over cos squared. You also know sine squared is 1 minus cos squared. And that's also a difference of 2 squares. And you know that cos squared is 1 minus sine squared. And that's also a difference of 2 squares. 1 minus sine, 1 plus sine. Right? So it's all derived from here. Now you don't need to write it. It's here. There's it. Here's it. Sine squared is equal to 1 minus cos squared. And that is a difference of 2 squares. 1 minus cos, 1 plus cos. Now, let's start. We start from our hectic side and we simplify it. Identities, like I always explain. Are you there, hasanain? Hasanain, go on.
For
Where's
sure.
my bra?
I am here.
Right. Hey, they want to go till 12 o'clock tonight. Are you listening to that? Lani Zati say, let's go till 12.
Good luck.
This
program can go on autopilot. We wish you guys luck.
Serious. Okay, now, hasanain, identities, we want to prove left-hand side equal to right-hand side. So say 2 brothers, you want to prove that they look identical. Now the 2 brothers, the one came from war and the other one's in his boxer shorts, right? So the one who goes to war, he's got the gun, he's got everything. You need to prove them to be identical. Common sense tells you, will you load the one to make him look like the other, or will you just put them both in their boxer shorts? Unload them, right? Put them in their boxer shorts. So that means, how do we remove all that heavy weight? We use the algebra, we remove surd signs, we remove brackets. So we start with the hectic to make it look simple. We don't start with the simple to make it look, because the question in maths is to simplify, not complicate. Okay, so we're proving identities. So here we go, 2 steps, Ali. Let's go prove, watch here. Prove that sine x plus cos x all squared is equal to 1 plus 2 sine x cos x for 4 marks. Left-hand side, right-hand side. So we start with a loaded side. So let's start with the left-hand side. What is step number 1? Algebra. So that means this is sine x plus cos x into sine x plus cos x. The algebra, we FOIL. First, outer, inner, last. Sin x times sin x sin squared x plus outer sin x cos x, inner sin x cos x, last, my two last terms, cos times cos is cos squared x. So there we go. AL, algebra. Who does identities? Ali. Now we look for our identity. Sin squared plus cos squared is how much? 1. No, sin squared plus cos squared is 1. Sin squared over cos squared is tan squared. Sin squared plus cos squared is 1. 1 sin x cos x plus another 1 sin x cos x is what? Plus 2 sin x cos x. And there we go. Left hand side is equal to right hand side. Game over. Ali does identities. Ali does identities. Ish, boxer shorts and vest with sandals. Yo, that I know is a Aldo's Westbury nuclear move, bruh. Where the long soccer socks, the Adidas sandals, the Mr. Price Max shorts, out the vest, no muscles, but the is scroll. He looked like a toothpick with, he looked like a matchstick with 2 panados. Yeah, ne? I know, Owens came today to the maths class in winter, mid-winter, sloffies, socks, and they think it looks cool. 2 cos b equal root 2 and a plus b equal 90. What is sin 2a plus sin 2b? Jacques, the place to be, Lynette, the place to be. Maths cut. Right, you took this one down. 5 minutes left. Let's give you another one to do. I'm clearing the frame. Oh, okay, while you're taking that one down, Ali does identities. Let's do the next one, guys. Right. Right. Prove that sine theta over 1 minus cos theta plus sine theta over 1 plus cos theta is equal to 2 over sine theta for 5 marks. Prove. Go for it. Tala what you must. Left hand side. Start on the left hand side. Use algebra first. Sort out your algebra. Let's see what my brasser online say. Let's see what my brasser. Facts, Alia. Facts. Ali for the win. Miley clues. Tyrese is broken. Tyrese is stucken. TK 5-1. Stitches. Right, do this one, guys. Just like that, Linda. Just like that. Your bronchospray. You know, bronchospray, they say, is the only cemetery above the ground. Because they say everybody's dead. That's what I heard. I don't know. Prove me wrong. Show me what the skirt bronchospray is. Then maybe we dala something in the bronchos. Last one, guys. Last one. We're going to finish trigs after break. In fact, after break, before I do analytics is easy. We're going to start with Euclidean after break. I'll do one more identity and then we'll do Euclidean. It can't be 1 over sin A. Look at the right hand side. It's got to be 2 over sin A, Baba. My sister from another mister. My brother from another mother, or my sister from another mister. Let's we go. Right, left-hand side. Left-hand side. Ali, AL, algebra. So LCD, we're adding two fractions. 1 minus cos theta into 1 plus cos theta. Right? Algebra, we're doing LCD because we're adding. 1 minus cancels. 1 plus cos times sine is sine theta into 1 plus cos theta plus 1 plus 1 plus. We left with 1 minus times sine is sine theta into 1 minus cos theta. Right. We're not yet done. Algebra is not done. Sine theta times 1 is sine theta plus sine theta cos theta. I'm multiplying it out. Distributive law. Plus another 1 sine theta minus sine theta cos theta all over difference of two squares. 1 minus cos squared theta. Now, plus sine theta cos theta minus sine theta cos theta cancels out. Sine theta plus sine theta, 2 sine theta over 1 minus cos squared. Here's your identity. Here is your identity. Ali does identities. AL and I. 1 minus cos squared is sine squared theta. So that's 2 sine theta. And if you want to, you can break the sine theta up, sine squared into sine times sine. Sine theta and sine theta will cancel out. What am I left with? 2 over sine theta, which is equal to your right-hand side. Bada bing, bada boom. 12:30 on the dot like a boss. Time for break. Time for break. You done and you got it right. Well done, Alia Rauf. Well done, well done. Give yourselves another round of applause. We're done with 2 rounds. We got one more. Well done, Bakang. Well done, Tepiso and everybody else. Mukhtar, Gudat. Got it, got it, got it, got it. Good. Larato. Well done, well done, well done, well done. Mikenzo. Break time. Chauke is hungry. He wants Skamban. You know Skamban. Like a boss, TK. Right. It's 12:30 now. Hasanain. I think we regroup at 1:15. Am I right? 1:15 p.m.
So there we go. That's the program for today.
We're going to start you. I'm going to do another identity after break, and then we'll do some Euclidean.
So tell me, are we going to shorten? Are we going to shorten? Going to have to shorten the break because you've accommodated the shortfall of yesterday.
I don't know. No, I think their brains are fried. If we only give them 30 minutes, they're going to die. So let's just keep it. Let's keep the time. Let's keep the time.
Sure. So we'll see you after the break.
Okay, I see you after the break. And welcome, Keith Monofukutwa. You New Year. Hey, you missed a lot yesterday and today, bro. Okay, we'll do general solution also immediately after break. Okay, guys, enjoy your break. Bye.
So there we go, guys. That's break time now. We will resume after. We'll have about an hour break, and then we'll resume again. So you can get some time to have a short nap, have a break. So we'll resume at 1:30. And kindly be advised that we will be resuming at 1:30, and send us your comments and your suggestions. Let us know if you are enjoying this. You can pop me a mail, hasanain at awqafsa.org.za. Give us your feedback. Let us know what parts of the workshop you really enjoyed and how we can improve on it. I'm just going to share the Awqaf SA's website, and we're going to be showing you some more information on where you can find the videos of yesterday's session. So let's do that for you. So this is the Awqaf's website, awqafsa.org.za. So you navigate onto the homepage. All of our social media is here. You can click on the YouTube icon that will take you through to our YouTube page, which you need to subscribe to. And then this is an important page. This is the Awqaf SA Maths Workshop page. We're doing it for grade 11, 10, as well as 12. So you click on the button and that will take you through to the event page. And on the event page has all of the registration information for the events. If you want to register for the grade 12, it's happening next week at the Al Ghazali College in the Wall. That's in the Erasmus Centurion. You can register and that takes you to the registration page. These are the videos of the 2 days. That's Maths Paper 1. And then you can view the session over there if you missed out on anything. And that is Maths Paper, let's have a look here. This is Maths Paper 2. We're currently looking at ourselves. So you missed out on anything. Maths Paper 2, the videos are here. And you won't miss out on anything. Let's give you a view of the... So there we go. That is information pertaining to the Awqaf SA event page. Stop sharing that. So we're gonna play another. We're gonna play another of Rory Sang's videos. This aims to add some motivation to you. This Rory Sang, he was a grade 12 participant. He took part in our workshop and he scored 100%. And as part of our competition, he placed in first prize. He received the first prize. And our competition is about awarding academic excellence to top performers in the exams who have taken part in our workshops. So this is Rory Sang.
I believe that you can derive great value in attending the Awqaf SA mathematics workshops. I have gotten a lot of help from them and I have a lot to show for it. So please just check that out and keep on working on your dreams and ensuring that you have a bright future for yourself. Lastly, I would like to thank Awqaf SA for their commitment in essentially building a better South Africa, because we know that in future careers that will be in great demand are those that involve science and mathematics, and by attending these workshops you'll be able to ensure that you participate in the future economy by working in these industries. So thank you very much to Awqaf SA and good luck on your examinations.
So there we go, address from Rory Sang. He continues to serve as Awqaf SA's Maths Workshop. So I believe that through this workshop, we will be cultivating and encouraging academic excellence in mathematics. It is your future, and we are here to assist you. So I'll see you on the other side after the break. We're just going to take a short break now.
Water, the most precious blessing from Allah. It sustains life, purifies humankind and the earth. But for many communities in need, access to water is a daily struggle. Awqaf South Africa's Water and Sanitation Awqaf Fund is dedicated to assisting these communities with access to clean water. In a drought-prone country like South Africa, the need is hard to quench, but the joy and gratitude of those who benefit from it are immeasurable. Just one borehole can cost as much as 80,000 rand, requiring an initial investment of 800,000 rand. But when we all pitch in, it's doable. How much will you pitch in? Visit our website and donate to the Water Awqaf project today. Imagine losing your sight and feeling like the world around you is slipping away. For many elderly people in South Africa, this is a reality. In South Africa, every year 200,000 people need cataract surgery to restore their sight and quality of life. With the Awqaf South Africa Cataract Project, we're working to make that happen. Since 2005, along with our partners, we've funded over 8,000 surgeries, giving the gift of sight and hope to our elderly community. But there's still so much more to be done. With your help, we can restore the gift of sight to even more of our precious elderly, and with it, the blessing of restoring their dignity. Join us in our mission to help people move from darkness to light. Pledge your support today. Awqaf South Africa Cataract Project, making a difference in the lives of those who need it most. When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, and communities celebrate. Awqaf South Africa, a charitable Awqaf organization, makes it easy to share the care. All donations are plowed into Sharia-compliant investments, while the fruits support a wide variety of charitable causes. Visit awqafsa.org.za to discover how your Awqaf can bless our community with a legacy of care.
We're back with a bang. We're back with a bang. Hope that you guys are feeling amped for round 2 of the maths workshop. I know Mr. Kota is definitely feeling it. I definitely want to show you guys something. Mr. Kota, I've also got some tricks up my sleeve. So let me just show you that quickly. So on our YouTube platform, you can see the screen of the YouTube platform.
Yeah. I'm seeing that.
See, if you click in the chat bar, there is something that's got a S, like a S and a dollar signs.
Okay.
So with the super sticker, if you, your family, or anyone has got some disposable income and you want to support Awqaf, you can support Awqaf by using the super sticker. So you click on that and you send that to Awqaf, and that will be like contributing towards Awqaf and their efforts. Of course, this is dependent on you having a Google Pay. Either your parent can assist you with that Google Pay account. So it's dependent on that. So you can have these different options.
Okay.
Right, so let me show you this one over here. This is called a super chat, right? So you can start from 14 Rand up to 101.4. So let's go for like 70 Rand, buy and chat, buy and send. So this contribution goes through to Awqaf, and we can support more people with that. So that's just some information that I thought that I'll share with you. Over to you, Mr. K. Take the show away.
Right, we're back, and we're back with a bang, and it's not round 2, hasanain, it's round 3. This is the third session for today.
Round
So,
3, fight.
Round 3, fight! Let's go. Let's take this away, guys. This is where we ended up with the identities before break. And now we're going to go into general solution, guys. We're going to do some general solution. So we know for sine, it's our answer plus k times 360, where k is an element of integers. For cos, we put plus minus the angle plus k times 360, because a complete sine graph and cos graph makes its appearance every 360 degrees. And for tan, it's your answer plus, hey, Mr. Nub, don't give me stories now. Let's erase that. You just want to close that door for me, please. And let's go back to our pen, plus k times 180, where k is an element of integers. Right. So this is what we call, guys, the general solution. And then the minute they give you a restriction, then you got to substitute all your integers. 0, 1, 2, minus 1, minus 2. And whichever of your answers fall within the restriction, those will be your possible solutions. Now, we did the 5-block rule for reduction. We did Ali does identities. We did scrap, standard form, Cartesian plane, restriction, and Pythagoras. I'm going to give you a new one for general solution. You do it like this. SSGR. Stupid students get rabies. Right. So this is an acronym.
Hi. Hi, Bo.
The first S is for, put it into standard form. The second S is use the shift key on your calculator to get your answer. The G, obviously, attach your general solution. And the R is your restriction. So obviously, please don't go and write SSGR in your paper. This is a mental process of how to answer this. You go and write SSGR, your principal or your marker will write there, yo, what the freakadelle?
SJ.
SJ, yeah.
See, some of your ways have rubbed off, Mr. Ken.
I'm seeing slowly. I think in another 1 or 2 workshops time, hasanain, I'm going to have to rap you on your knuckles and give you yellow cards, bro.
Put me in the naughty boy corner.
I'm going to put you in the naughty boy corner. Right, so let's give the general solution. Let's give you a scenario. Let's say 5 sine theta plus 10 degrees is equal to 3. And theta is an element of 0 to 360. Right? So they can either say give the general solution, or they can say solve for theta for 6 marks. Question, answer. Right, take this one down, guys. I hope you guys are feeling us. I hope you're vibing with us. Letlokonolo still says she's still fresh. Letlokonolo says she's still fresh. We are mathsing. I hope you guys are still vibing with us here on this bumper weekend. Stross is back.
Levels.
Let's go. Right, let's dala. Standard form. So put it into standard form. The first S, theta plus 10, is equal to 3 divided by 5. That's opposite over hypotenuse. There we go. Standard form. Now we use the shift key. So now theta plus 10 is equal to That's quadrant number 1. And it's for sine. We're going to put quadrant number 2. Theta plus 10 is equal to 180 minus. Remember, quadrant 1 is 0 degrees plus. Quadrant 2 is 180 minus. So the minute we do that, we do this. We split it up. So let's go to our calculators, guys. There's your calculator. Make sure your calculators are on degrees on the top, the D. Shift sine 3 over 5. Shift sine. We're using the shift key. Shift sine 3 over 5. Let's go. 3 over 5. Boom. 36,9. 36,9. So we use the shift key. Now attach your general solution for sine plus k times 360, where k is an element of integers, or 180 minus 36,9 plus k times 360, because sine is positive in quadrant 1 and quadrant 2. Now we solve for theta. So theta is equal to 36,9 minus 10 is 26,9 plus k times 360, where k is an element of integers, or theta is equal to 180 minus 36,9. 180 minus 36,9 is 143,1 minus 10 is 131, 133,1. And here's your two solution, 133,1 plus k times 360. You don't touch, it doesn't affect your general solution, where k is an element of integers. And there we go. There we go. We are done. There's your restriction. Quadrant 1, quadrant 2, 0 plus. 0 plus is the same, or 180 minus. That's your reference angle. Your angle stays. Your angle stays. So reference angle is equal to your angle, or reference angle is equal to 180 minus. And there we go. And there we go. You'll get 6 marks for that. We use SSGR. Stupid students get rabies.
No.
The funnier it is, the more you'll remember it in the exam. So what will your final answer in your exam look like? You don't need to do that or that. You'll just do this or that. Just showing you what it would look like, your template. And that's what your answer would look like in your exam. If you wanted to, you could say quadrant 1 and you could say quadrant 2. There we go. And that's your template. And that is your template. Are you guys feeling me? Are you guys feeling me? Got it, Keith? Are you loving it? Can you see how easy it is? Can you see how easy is it? It is. Let's check the mathematics. It's simple. Now, if they gave you a restriction, now obviously you'll put in your restriction 0, 1, 2, minus 1, minus 2, 0, 1, 2, minus 1, minus 2. Whichever answers fall within your restriction, those will be your possible solutions. So you've taken it down. Those of you who took this one down, let's do one in terms of let's do this one. Let's see you guys do the next one. Let's see you guys do the next one. 210x plus 10 equals 2, 5. Let's see. 2, divided by 2, 1,25, shift 10, 5. Yes. All right, let's see you guys do this one. Here's another one for you to do. Where is it? There we go. 210x plus 10. 210. Watch here. 2x plus 10 minus 2, 5 is equal to 0. Give me the general solution. Right, let's do this one. Right, do you guys want to do it on your own, or you want me to do it for you? You want to try it on your own? This is in terms of tan. This is in terms of tan. Your reference angle is 2x plus 10 not just x. It's 2x plus 10. You're feeling me. That's good. I feel all your energy. That's what powers us up. Your energy powers us up to carry on and deliver better for you. Still vibing. Mbata. On your own. Right. Dala Amanda. Ngoveni. Slap it. Whack it. Destroy it. Show them flames. Time to show maths flames. Time to show flames, bruh. I like that, Sindile. Let us handle it. Or let you handle it. You want it, let you or let us? Ayanda says on our own. On our own, Kopano. That's what I like to hear. Leave it to us. We'll dala it ourselves. Right, Miley? We're finishing up with this and we're going into Euclidean. You should be done by now. And it's in terms of 10. So please make sure you attach the right general solution. Don't stuff it up. Punch maths in the maths. Yeah, something like that, Anna. You should be done. Can we crack it together? Can I do it for you now? You should be done. I see some people, their pens are going down here. People are working. They are spunning, grafting in the grind. Are you ready? Do you think you're right or you know you're right? Do you think you're right or you know you're right? Okay, so Kenneth has come up with an answer. I don't know yet. I don't even have the memo. I'm doing it. I'm going to be doing it with you. Letlokonolo, done. Aware. Let's see. Let's crack. Right, let's go. Standard form. Stupid students get rabies. Standard form. Let's take the 2,5 on the other side and then let's divide it by 2. That's standard form. So 10, 2x plus 10 is equal to 1,25. Now we use the shift key. Shift 10, 1,25. Shift 10, 1,25. Boom. 51,34. So 2x plus 10, reference angle. There we go. Copy and paste. Is equal to 51,34, 51,3 plus k times 180. And here you don't need to give two general solutions because it's 10. Right. So now let's solve for x. 2x is equal to 51 minus 10, 41,3 plus k times 180, where k is an element of integers. So x is equal to 41,3 divided by 2. And 20,65 or 20,7. 20,65, 20,7, both answers are right. Plus k times, we divide that also by 2. 90, where k is an element of. Boom. How many of you got that one right? Give us a thumbs up there. Right? They didn't give you, so Letlokonolo, they didn't give us a restriction. So you just leave it like that. Just leave it like that. 20,67. You'll get your full marks. Don't stress. Kifilwe, it's me. Wow. Kway, Mulisa, everybody, you are getting it. Right, let me give you a different style. So, what if they told you sine squared x is equal to sine x cos x? Give the general solution. for 5 marks. Come, crack this one. Do this one on your own. And I'm going to show you one more style of general solution after this. Then we're done. Then we start hitting, it's 20 to 2. We then start hitting Euclidean. I'm going to show you all the laws of Euclidean geometry, all your circles, and we're going to start applying it.
Where's Zidane?
Zidane didn't come today. He must be online. I don't know where's my bra.
Holla back there.
Zidane says, I know I'm right. That's the spirit. I don't think I'm right. I know I'm right. TK, like a boss, Baba, like a boss. Hasanain, we're really vibing with these grade 11s.
For
we
sure.
pray that they're going to do well now in June. They're going to give us all their results.
For
and,
sure.
Yeah, end of the year, they are going to make us proud. In fact, this group next year is going to be my star group for grade 12. They're going to be cracking math, dalaing it like they've never seen it before. They never saw marks like this before.
2024.
This is our class, 2024 class.
Sure.
Inshallah. Say Amin, guys. Say Amin.
Amin. And the levels will increase.
Of course. Right. So what do we do here? Sine squared x minus sine x cos x is equal to 0. Take out your highest common factor, sine x. We are left with 1 minus cos x is equal to 0. Sine x times 1. Hey, no, I lie. Is sine x there, brah? Sine x, we take out that, that's sine x. Correcto mundo. Now we got two solutions. Sine x, this is a quadratic. Sine x equals 0 or sine x minus cos x equals 0. So x is equal to shift sine 0, 0 degrees, plus k times 360. You have to put it in. Do not discard it. Or x is equal to 180 degrees plus k times 360, where k is an element of integers. Or on this side, sine x will equal to, take the cos on the other side, is equal to cos x. Now divide by cos. Cos over cos is 1. Sine over cos is tan x equals 1. X is equal to shift tan 145 degrees, your special angle, plus k times 180, where k is an element of integers. And there we go. You got yourself 5 to 6 marks. Marks for jam, marks for mahala. Did you guys get that one right? That's how you do it. You must check sometimes. It's a Simone Arendt says the class of 24 will produce a great number of maths distinctions. Of course. Kifilwe says, I'm correct. Woohoo. Kudos for you, brah. No decimals. No Tsechovato. Okay, in the previous one. Yeah, it's fine. In the previous one. Well done, Miley. Well done, Zulfika. Good for you. Let's see if you guys can do the last one. Anna, away, danko. Danko. Let's see if you can do the last one. Give me the general solution for 6 marks. Show me where sine x minus 30 is equal to cos 2x for 6 marks. I want the general solution. What you guys say? Next week, Saturday, we have another workshop. You ready? Are you ready for next week? June holidays, we have another workshop. You ready? Yes. We're going to show maths flames, Baba. Sindile, Oh, please be my maths teacher forever. I'm with you in spirit. Inshallah. Inshallah means if God wills. Inshallah. Don't worry. We're here for you. Grade 11s, we're here for you, bruh. You guys just be in contact with Awqaf. You send them SMSs, you flood hasanain. You tell him, hello, we want more.
And who's going to tutor me for my exams, my communication exams?
Hey,
I also need a
sorry,
tutor
ne?
there.
5, 4,
Yes.
3, 2, 1, sorry, ne?
Sorry.
Sorry. You see, you're also losing it, bruh.
No,
What was
it's
it?
Gem Ellie. It's Gem Ellie, man.
General Solution. Oh, we got 1 year. Hey, somebody came here and brought me, Zaid brought me a cracker general solution to do. We'll do it after this. Okay. Are you sure it's general solution?
Show it on the
Okay.
screen, Mr.
Are this
Kway.
grade 11 or grade 12? Your SBA. Okay.
Show it again, Mr. Kway.
Okay. Right. Let me see. I can't. There we
Okay.
go. 1 minus cos
Good.
squared 2x over 4 cos 90 plus 2x is equal to 0,21. I don't know where is he bringing this one from. I hope he's right.
Hope he's not smoking anything.
Which one? Which one? Let me see. This is easy so that we can understand because some of us aren't that fast. Okay, but you're understanding this. We broke it up. We took the highest common factor. Okay, let's go. The next one. Now listen, Mamela, open your ears. This is a different style. This is a different style. So now watch what we do. So now you're going to say sine x minus 30 is equal to change the cos to sine. So that's going to become sine 90 minus 2x. Because sine 90 will change to cos. Here you can't divide by cos because you got two different angles. So you convert the cos to sine. Now you cancel that out. So now you got your two solutions. X minus 30 is equal to 90 minus 2x plus k times 360. I hope you guys have done this in school and this is revision and that you're not doing this with me for the first time. That's quadrant 1. Quadrant 2, 180 minus. So x minus 30 is equal to 180 minus 90 minus 2x plus k times 360. Where k is right, let's solve for x. X plus 2x, 3x. 90 plus 30 is 120 plus k times 360, where k is an element of integers. X is equal to 120 divided by 3, 40 degrees, plus k times 360 divided by 3, 120, where k is an element of integers. Or quadrant 2, x minus 30. I'm just doing the algebra now. We're removing the brackets. 180 minus 90 plus 2x plus k times 360. So we got x minus 2x, x minus 2x, minus x. 180 minus 90 is 90. 90 plus 30 is 120 plus k times 360, where k is an element of integers. So x will equal to minus 120 minus k times 360, where k is an element of integers. And there we go. There we go. Uyanda Kubeka, okay. We haven't started it, but I understand like I've done it before. Well done, Kemo V. First time doing it, but at least you're understanding. %, Pambili. First time doing it, Uyanda. Doing it for the first time. As long as you keep on replaying this over and over and over, you will understand it. Vuchila, first time, Your teachers will still get to it. I just showed you the different styles in which general solution can be asked. And this is how you dala it in your exam. Let's look at this last one here. Just switch on your screen again. This guy want to kill me here, bruh. He said it was in his SBA. Are you sure, ne? Okay. Let's write the question down. This guy want to kill me here, put me under pressure. 1 minus cos squared 2x over 4 cos 90 plus 2x is equal to 0,21. Chop. She posted the memo.
Yeah.
Okay. You got the memo? Yeah. Let me try first. Get the memo. Let's see. We dala it first. You know me. I look at memos last. And it was for 6 marks. So let's see. But now you see 1 minus cos squared 2x is sine squared 2x. That's a grade 12 question. I don't know what she did there. Okay, let's just try. I'm hoping this is a grade 11 because I can solve this in a grade 12 manner. I'm just trying to solve it in a grade. So now we got 4. Cos 90 will change to sine. Right? Cos 90 will change to sine 2x. But be careful. 90 plus is in my second quadrant. Cos in my second quadrant is negative. Are you with me? All right. Let's do it together. Is equal to 0,21. Now let's see. We need to get this into standard form. Let's get rid of the minus 4. So I'm going to times this side by minus 4. I'm going to times that side by minus 4. So that and that will cancel. 1 minus cos squared 2x over sine 2x is equal to 0,21 times minus 4 is what? 0,84. I don't know. Work it out. 0,21 times minus 4. 0,84 minus 0,84. Okay, we understand what we got there, what we did there. Now this is cos squared 2x, sorry, cos squared 2x. Because 2x is our reference angle. Let me see. You know, 1 minus cos squared 2x is sine squared 2x. 1 minus cos squared 2x is sine squared 2x. Right? That's our identity. Grade 11. 1 minus cos squared is sine squared over sine 2x is equal to minus 0,84. Now that and the one of them will cancel. So now I'm left with sine 2x is equal to minus 0,84. Now we do general solution. So there's its standard form. It took us all of that to get to standard form. Now we use SSGR, use the shift key. So shift sine 0, so 2x is equal to shift sine 2x. Now where is sine negative, guys? So shift sine minus 0,84 is minus 57,14, right? Where is sine negative? Sine is negative there or there. So it's going to be 180 plus or 360 minus. So watch what happens now. So now we're going to say sine 2x. Watch. Shift sine minus 0,84. Shift sine minus 0,84 will give me minus 57,14. So 2x is equal to quadrant 3. So we have to do quadrant 3. and we got to do quadrant 4. Quadrant 3 is 180 plus. Don't worry about that negative. That one only indicates quadrant. 57,14 plus k times 360, where k is an element of integers. Quadrant 4, 2x is equal to 360 minus 57,14 plus k times 360, where k is an element of integers. X will equal to 180 plus 57, 180 plus 57,14 divided by 2, 118,57, 118,57 plus k times 360 divided by 2, 180, where k is an element of integers, or in my fourth quadrant. Check your answer, check your memo. Check your answer, check your memo. We dallad it like a boss. I don't think I'm right. I know I'm right. Let's go again. 360 minus 57,14. How about a cup of coffee? Divided by 2 equals 151,43 plus k times 180, where k is an element of integers. Is that your memo? Bring that memo. We'll show that memo how to slat it. Bring it. There we go. There we go. 118,59. We got 118,57. Perfect. But this one here that she did, her memo was incorrect because the other one is minus 28,57. Right? She's still got to do the 180 minus. So our answer is correct. Because look here. If you did minus 28,57, 1 times 180 is 180. 180 minus 28,17 is going to give you this 151. So we don't think we're right. We know we're right. We don't think we're right. We know we're right. Bring anything. We dala it here live.
We know what is what.
We know what's cutting here. We'll show Maths flames. They mustn't try and dilela with us. Wala kan dyan. No makan dyan. Pagamisa.
Oh no, there goes the neighborhood.
There goes the neighborhood. Sabella like a boss. Fundy Pauls more.
Oh no.
That's it, TK. That's it, Letla Khonola. We are showing the memo flames. We are showing the memo flames. I've never seen one like this in my life. The one that he brought now, he just brought it fresh from the oven, hot off the press. He said, dala it for us. Put me on the hot seat. Right. We are done. Now we know how to do it. I promise you, a problem like this will be about 6 to 8 marks in your exam. It was 6 marks. I told you, 6 to 8 marks in your exam. Guys, are you feeling math? Are you feeling it? Right. Let's now go. Guys, we're starting with Euclidean. We're starting with Euclidean. Love you guys lots. Lots of love from Kway and Awqaf here from Cape Town and Johannesburg. What a weekend, guys. What a weekend. To find out if the identity is invalid, Sindile, your denominator can't be 0. It will become undefined. Any value that makes it undefined will make it not valid. Okay? So here goes more. You want more? Right. We want more. Let's give you more. Right. Let's clear the frame. Right. Let's start with Euclidean. I'm starting, guys. I'll show you. Let's go through all your theorems quickly before we start attacking. Right. So Euclidean, we're doing with circles. We're dealing with circles. The first thing you need to know in a circle, a cyclic quadrilateral means all 4 points touch the circumference. The first rule of a cyclic quadrilateral, the exterior angle is equal to the interior opposite. So write this, the exterior angle. When I say L, it means angle. And I'm writing it in short. Exterior angle is equal to the interior opposite. The second one, let's go through all your theorems together. The next one, if we got a cyclic quadrilateral, all 4 points touch the circumference. The opposite angles are supplementary, x plus O. The opposite angles of a cyclic quad are supplementary. They add up to 180 degrees. They are supplementary. Complementary means they add up to 90. Supplementary means they add up to 180. Law 1, Law 2. I'm not giving it to you in the order in which your schools give you. There are 11 theorems here. I'm giving you all. Learn all the theorems. Oops, sorry. Let's go back. Press the wrong toggle. I press delete. There we go. Right. Nunuberry, we'll do analytics. Analytics is very easy. We'll end up with that if we got enough time. But let's do the Euclidean because I know everybody was crying for Euclidean. Analytics is just finding the distance, finding the gradient, finding the equation of a straight line, parallel line, perpendicular. That's it. We'll try and end up in the last 15 minutes with analytics. Close the door for me, please. So there we go. I gave you the first two. I'm clearing the frame, guys. What happened here now? There we go. Right. The next one, theorem number 3. Very important one. Equal chords subtend equal angles. Subtend means you put your fingers on the two ends of the line and you see where it meets at the circumference. So equal chords subtend equal angles. So there's two triangles here. That angle is equal to that angle. So equal chords, there's it, only one chord. Equal chords subtend, like extend or subtend equal angles at circumference. The next one. You all know this. The bow tie or the butterfly. Angles in the same segment. All 4 points must touch the circumference. Then that angle will equal to that angle, and this angle here will equal to that angle. So angles in the same segment. So whenever you see the bow tie or you see the butterfly, angles in same segment at circumference are equal. So what we did, what number was this? Number 3 and 4. Right. Now we're going to go on to 5, 6, 7, 8, 9, 10, 11. Know them by memory. I'm not going to do the proofs of them here. Proofs is bookwork. You can just study that from your textbook. Your teachers will give you that at school. Let's do so equal chords. Right. Watch this. Next one. Number 5. Right. When you see, okay, no. Let's do number 5, this one here. Wait, not even that one. Let's do this one. Line drawn from center of circle to the midpoint of a chord. Line drawn from center of a circle to a midpoint of a chord meets it at 90 degrees. Line drawn. It's not a radius. It doesn't touch the circumference. Line drawn from center of circle to midpoint of a chord. You got to know this for grade 11 and 12. It meets it at 90 degrees. Number 6. Now when you got a quadrilateral that starts from the center of a circle and all 4 points don't touch, So now only 3 points touch the circumference. So O is the center of the circle. Angle at center is 2 times angle at circumference. So if that is 20 degrees, that one will be 40 degrees. Angle at center equals 2 times angle at circumference. And that's when you see the shape. When your quadrilateral starts, or when your, so it can look like that also. It could be a quadrilateral, or your bow tie starting from the center of your circle. That's number 6. Number 7. When you see the spearhead shape, like this, like a spearhead, it looks like that, goes like that, comes down like that. Exterior angle at the center is 2 times angle at circumference. So if that is 30 degrees, then this angle will be 60 degrees. So, and it could look, it's got 2 shapes. It could look like that, or it could look like this. Exterior angle at center is 2 times angle at circumference. So exterior angle at center is equal to 2 times angle at circumference. Learn all of this, guys. Learn all of this. I'm taking it down for you. I'm giving you all your theorems. Right. The next one. A diameter. A diameter subtends a 90 degrees. A diameter subtends a 90 degrees. So we call that angle in a semicircle. 90 degrees. So a diameter subtends 90 degrees at circumference. What number was this? 8. That one was 8. Oh, that one was 7. All right, so that one's 7. That one's 8. Let's go to number 9. Let's go to number 9. A radius is 90 degrees to a tangent. A radius or a diameter. It could be a diameter also. It's 90 degrees or perpendicular to a tangent. And you know what is a tangent? A tangent touches at one point. Number 10. The tan chord theorem, very important. You must have a cyclic triangle. All 3 points must touch the circumference. Then angle between tangent and chord is equal to the angle in the alternate segment. So that will equal to that, and that angle will equal to that angle. So we call this the tan chord theorem. So what does the theorem state? Angle between tangent and chord. There's it. Angle between tangent and chord is equal to the angle subtended at the circumference in the opposite or in the alternate segment. In the opposite segment. That's the full theorem. But when you're writing your reasoning, you just say tan chord. They'll know exactly what you're talking about. And let's do number 11, the last one. We're almost there, guys. Hang in there. Two tangents meeting at a common point. So let's have a point there. Let's have a line going like that. And let's have a line going like that. So two tangents meeting at a common point outside the circle are equal in length to where they touch the circle. So if I call this A, B, C, AB will equal to AC. AB is equal to AC. And your reasoning, two tangents meeting at a common point. Two tangents meeting at a common point outside the circle are equal in length to the point of contact of the circle, to the point of contact to the circle. And there we go, done. Right? So these are our laws. Let's now start dialing some exam questions. Grade 11 questions. Okay. You will always find they'll give you one with Pythagoras to do first. Before they give you the circle analytics and ask you to prove, it's so easy, Euclidean. You're going to get a Pythagoras. You're going to get one theorem to prove. Then you're going to get a couple of easy problems. And that will be, if it's out of 50 marks or 30 marks, at least 20, you'll only get one difficult rider at the end. So you can't fail this section. It's easy. All right. Onliners, we okay? Can I clear the frame and can we start with some exam questions? Converse and corollary is the same thing. The converse, it's the opposite of a theorem. Okay. Right, so let's go. Let's go. Let's apply. The purpose of today is to start applying. So let's start applying. Let's clear the frame. Now, what I want you guys always to do is look for what do you look for? What do you look for? You look for radii. You look for diameters. You look for isosceles triangles, very important. You look for parallel lines. And then you look for the various shapes. You either look for the bow tie, which is angles in the same segment. You look for angles in a semicircle, which is 90 degrees. You look for that spearhead shape that I showed you. Exterior angle at center equals 2 times angle. You look for cyclic quads. You look for cyclic triangles for tan chord theorem. The minute you see a tangent, tan chord theorem. And you're always going to be using sum of angles of a triangle. And you'll also be using exterior angle of a triangle is equal to the sum of the interior opposite angles. That's what you're going to be looking for in diagrams. So let's give you a diagram and let's start identifying few things. So here's a diagram. So they give you this. They give you, check this. They're giving you a diameter. You already know what you're going to be using. You got a diameter, right? Then you got radii. So you know isosceles triangles. There's it. Then you've got another triangle coming down there. Then you've got a cyclic quadrilateral. So you've got that going there. And you've got this coming there. Look at how much. It's a loaded question. This is point A, B, C, B, O. That's O2. That's 56 degrees. And that is 26 degrees. And that's Z. And that's X. And that's Y. So find the value of X, Y, Z. Find the values of X, Y, and Z. This is level 1. We're still picking it up. We're going to go into higher order. We're going to go into some more complex problems. I'm going to be doing about, maybe if time permits, it's 25 past 2 already. Probably we can do about 3 or 4 for today, just to get you used to working with it. So take the diagram down. Take the diagram down. Guys, we only got the last 35 or last 30 minutes to go. I told you before you know it, today is over. Yeah, we did that. Okay. So we're starting with this. Where do you want to begin? Sure, there's so much to begin. Diameter, triangle. So let's say in my answer, in triangle ABD, right? ABD. We know there's a diameter, it subtends at 90 degrees. Angle A is equal to 90 degrees, right? Why? Angle in a semicircle. Now you didn't need to start here. So if that's 90, that's 26. Therefore, angle Y is equal to 180 minus 90 plus 26. Y, sum of angles of a triangle, equal to 180. So angle Y is equal to, so 180 minus, open brackets, 90 plus 26, close brackets, boom, 64 degrees. So we know angle Y. So we got angle Y. Angle Y is 64. So what you do, go back to your diagram and put 64 degrees there. Now we need angle X and we need angle Z. Whichever one you want to do first, you are welcome to do. I'm going to go for X first. I'm going to tackle. I'm going to... I cleared the frame. Wait. Sorry. My bad. I'm going to tackle, yes, Kenneth, Y is 64. Well done. Well done. I see you guys are sharp like that. Right, now let's go back to this diagram. Check this triangle out here. That side is equal to that side, radii. So you have to say in triangle OCD. Who's OCD here, bruh? I'm OCD. Right. In triangle OCD, obsessive compulsive disorder, OD is equal to OC radii. Therefore, triangle OCD is isosceles. Therefore, X is equal to 180 minus 56. Minus 56, divide by 2, because that is also X. Divide by 2, sum of angles of a triangle. So X is equal to 180 minus 56, 180 minus 56, divide by 2, 62 degrees. So that is 62 degrees. Now there's so many ways of getting Z. There are so many ways. This is a cyclic quadrilateral. Can't I say opposite angles are supplementary? Guys, there are many ways. There are many, many, many ways to get Z. So let's find Z. So we got X, we got Y, we're short of Z. X, Y, Z, we need We got y is 64. We got x is 62. That's 62. Now we want to get z. We're going to say A, B, C, D is cyclic. We can see it clearly, duh. Therefore, z plus 26 plus 62 plus 64 is equal to 180. Why? Opposite angles of a cyclic quad. Opposite angles of cyclic quad are supplementary. So Z is equal to 180 minus all of this. 180 minus 26 minus 62 minus 64. Boom, 28 degrees. Let's see who got that one right. Did anybody get that? Hey, letloko nolo. Tandiwe, Linda. Well done, well done, well done, well done, well done. Masia, well done. Right, let's choose another one. We're picking up the pace. That's an easy one. Are you guys following? Are you guys following? Are we on the same page? Good, good. Here goes the next one. Let's delete. Let's take all that out. Here's a whole new diagram for you. Those of you who are still taking out, that's fine. Those of you who are done, you can start with the next one. Right, the next one has got a point there. It's got a line going there. It's got a line coming down here. It's got a line going straight outside the circle. It's got a line going there. It's got a line coming down here. That's touching the circumference. And it's got another line coming down across there. There we go. Anything else? No, nothing else. They tell you that this line is parallel to that line. So here's it, parallel lines. That is equal to that. Let's take this out. Let's label it. O is the center of the circle. This is 150 degrees. This whole angle here outside is 150 degrees. That's A. This whole angle is X. This is E. That is D. D1, D2, D3. B1, B2. And this is C. They want the value of X. Question number 1, find the value of X. Find the value of X. Question number 2, the size of C. 4 marks, 3 marks. Total marks, 7. Right, let's see, what do we have there? Interesting scenario. We've got parallel lines, we've got a cyclic quad, we got the spearhead shape. Lots happening here, guys. You make me coffee. You made? Oh, are you gonna make me? Yeah. Oh, lekker, man. Away. Right, where do you want to start? Find the value of X. I would start with the known. You always start with the known, the 150. So if that is 150, then angle at center is 2 times angle at circumference. Here's your spearhead shape. So if that's 150, then this angle is 75. So I'm going to say angle E is equal to 75. Why? Because angle at center is equal to 2 times angle at circumference. Now, because we got parallel lines, D3, therefore angle D3 is equal to 75, corresponding. Now, exterior angle of a cyclic quad is equal to the interior opposite. So x is 75. X is equal to D3. Therefore, x is equal to 75, because that's 75. And exterior angle of cyclic quad is equal to interior opposite. So exterior angle of cyclic quad is equal to the interior opposite. And there we go. We found the answer to question number 1. Find the value of x. X is 75. Calculate the size of C. Do this one on your own. Do that one on your own. The next one's quite easy also. If this is 75, B2 is also 75, corresponding angles. Angle B2 is equal to X, which is equal to 75, corresponding. And therefore, C will equal to sum of angles of a triangle. Therefore, angle C is equal to 180 minus B2 plus D3, 75 plus 75. Sum of angles of a triangle. So it's equal to 180 minus 150, which is equal to 30 degrees. And there we go. We are done. I hope you all got that. Now I'm going to give you a little bit. Yes, Zulfikar. Jazakallah. How many sugars? 1. Put it out. Put. Don't be shy. Me, I drink the sugar. I'm on a sugar high. Don't be shy. Me and sugar. Like Zuma say, we are like this.
Just watch out, Mr. K is going to be ingesting some caffeine intravenously. I think our rocket's going to go to another planet there, Mr. K.
Here goes my 5th cup of coffee for the day. I got problems. I don't have challenges in life. I got problems. I got a coffee problem.
Do you sleep?
Like a baby. And that's the challenge. One more sugar, brah. One more sugar. Dala the sugar.
Mr. Kota, you are not a human. You are a machine. A caffeine ingesting
Dala the
machine.
coffee as you must.
You are a machine.
Sure. This coffee is going to go down now.
Man or machine?
Beautiful. Let's go, Baba. Let's go. Let's Dala. The next one, she's going to hit you for a 6. You are going to be crying. Jibai. Jima. Jiben. This one here, she's bringing me other problems here. This one, she's making molatu. She's making matata. What, 7.2? But that's so easy. You want me to do it? Okay, let's do it for everybody. Okay, guys, let's do this one before I give you the killer one. Yeah, this one here, I just looked at it. She's not looking too bad. Right. So now O is the center of the circle. I've never seen this one before in my life. She's just giving it to me now. You know, these children. Ish. One.
Kota, I'll see you shortly. I'm just going to stretch my legs. So
Go
don't
stretch,
despair.
Baba.
Don't
Go stretch.
despair. I'm with you.
I'm going to miss you too much.
I miss you.
Right. Then this one here. Ish, these lines. They are making me mad. This one, she's going right outside the circle. Right outside. Sure. And then this one, she's going right outside like this. Hi, Bo. What are you doing here? What are you doing? And then you have got a line coming down like this. Yo, these people, they are not playing. B1, B2, B3. That's B. B1, B2, B3. Yo. This is A. This is O1, 2, 3, 4. O1, 2, 3, 4. This one is E. I'm taking it from your phone. D1, D2, D3. D1, D2, D3. C1, C2. C1, C2. Jo. And this is 10 degrees. That is 10 degrees. This is F. Okay. This line, she's equals this line. Yo. In the figure, O is the center of the circle. A, B, C, D, E. A, B, C, D, E. Correct. D, F, right. A, O, D, F. B, O, E, B, C, F are straight lines. Okay. Calculate giving reasons. Right. We want the size of the following angles. Question number 1, I want D1. Then I want A. Then I want angle O2. Then I want angle C1. Then I want angle E. Then I want angle C2. Then I want angle O3. I want the size of these angles. 3, 4, 2, 2, 2, 2, 2, 2. Mark allocations. 3, 4, 2, 2, 2, 2, 2. Marks. Go for it. Have fun. I want the size of these angles. Angle D1, angle A, angle O2, angle C1, angle E. Copy means the angle. Angle C2, angle O3. Question 1, 2, 3, 4, 5, 6, 7. Right, that one is yours. There's your phone. Let's dial. Hey, she's quarter to 3 already. We have only got 15 minutes. D1. Let's see. We're going to start off with what we know. What do we know? 10 degrees. That's all we know at the moment. You always start from the known, moving to your unknown. Where's D1? D1, she is there. What do I know? I don't tell me. This is an isosceles triangle, right? That side is equal to that side. That means that must also be 10 degrees, right? Then this, I know D2. Exterior angle is equal to the sum of the interior. So D2 is equal to 20. Exterior angle of a triangle is equal to the sum of the interior opposite angles. Now we know that this here is a bow tie. We know D1 is equal to B1. We want D1. Oh, we know this is radii. We know that is equal to that. So we know this is
an isosceles triangle also. So if that is 20, we know B2 is 20. I'm just trying to fill out as much as we can. This is a diameter. Diameter will subtend 90 degrees. So how much is D1? That is 20. So this must be 70. Hey, we are done. We are done. We are done. So let's go. Let's go. Let's go. We're going to say BD equals DF. BD equals DF given. Therefore, triangle BDF is isosceles. What? Where? No, it's D1 plus D2. Yeah. Let me show you. There's your triangle. There's your triangle. There's your triangle there. And this diameter will subtend 90 degrees at the circumference. Which? B? B? A? D? Yeah, this will also be. Yeah, you can even do that. Okay, but look, BDF is isosceles. BDF is isosceles. Therefore, B3 is equal to 10. B3 is equal to 10. There we go. B3 is 10. Angles opposite the equal side. Angles opposite the equal sides of an isosceles triangle. Therefore, D2 is equal to 20 degrees. Why? Exterior angle of a triangle is equal to the sum of the interior. Exterior angle of triangle is equal to the sum of the interior opposite. But D1 plus D2 is equal to 90 degrees. Angles in a semicircle. Angle in a semicircle. Therefore, D1 plus 20 degrees equals 90. D1 equals 90 minus 20. D1 is equal to 70 degrees. So D1 is 70. I don't know why they only gave you 3 marks. A question like this should be at least 5 to 6 marks. That's the answer to question number 1. Answer to question number 2. Angle A. Where's angle A? There. So we know if D1 is 70, we know this is 70. Right? We know B1. Angles, the bow tie. The bow tie. If D1 is 70, therefore angle B1 equals 70. Angles in the same segment. So that's 70. Angles in same segment. And then in the big triangle here, sum of angles of a triangle. So angle A is equal to 180 minus 70 plus 20 plus 10. 70 plus 20 plus 10 plus the other 10. Sum of angles of a triangle. Sum of angles of a triangle. Where that is equal to 180 minus 70 plus 20, 90 plus 100 plus 10 is 100 plus 10 is 110. And that is also equal to 70 degrees. Yes? Yeah, B1, yeah, but this is also 70 degrees. Okay, sum of angles. And it's also because this is an isosceles triangle. These two are radii. So there are 2 ways of doing it. So we got D1, we got angle A. What's O2? Where's O2? O2. O4. Oh, okay. So obviously sum of angles of a triangle. O2, 20, 20. So O2 is 140. Sum of angles of a triangle. In triangle OBD. In triangle OBD. In triangle OBD. Let's go. Let's dala this. Let's finish this question. Question number 3. In triangle OBD.
So we know angle B2 equals 20. We know angle D2 equals 20. Therefore, angle O2 is equal to 180 minus 40, which is equal to 140 degrees, sum of angles of a triangle. My hands are sore now. Now my hands, my fingers are throbbing. It's a problem. So we got O2. What's C1? We got O2. We got A, we got that, we got that. O2 is 140. Where are we going to even put it? We don't even have space to write in the 140. So let's write the 140. We have to put in the 140 somewhere. So let's take that out. We got 70. That is 140 degrees. What do they want? C1. Question number 4. Where is C1, Baba? Where is C1? Wait, let me just erase this. I know some of you are seeing it already. You are seeing C1. Question number 4. Where's C1? C1. So they want this angle here. Né? They want that angle there. Hey, here's a cyclic quadrilateral. ADCB. ADCB is cyclic. Therefore, angle C1 is equal to 180 minus angle A, minus 70, angle A. Why? Opposite angles of a cyclic quad add up to 180 degrees. Opposite angles of a cyclic quad. Opposite angles of a cyclic quad. Opposite angles of a cyclic quad. So that is equal to 180 minus 70 is 110 degrees. So C1 is 110 degrees. We're done with that. We don't think we right. We know we right. Onliners, how are we doing? No, C1 can't be 40, Sarah. Is 110. Opposite angles of a cyclic quad are supplementary. A, B, C, D is cyclic. Right. What do we need now? Angle E. Let's go to angle E. Guys, we're going to finish this. It's already 10 to 3. We got 10 minutes to go. Sorry, man. I can't do analytics. I'd love to have done it. But time. We are fighting against time. Right. So we need angle E, nah? Yes. Stupid me. I didn't see that one. Angle E is equal to 70, the bow tie. So we're doing question number 5. Angle E is equal to 70 degrees. Don't write bow tie. Angles in the same segment. Number 6, C2. 70. So you can either do it angles on a... This is 110. So you can either do adjacent supplementary angles on a straight line, or you can say exterior angle equal to interior opposite. So C2 is equal to 70 degrees. I would just say ADJSUP, adjacent supplementary. It means angles on a straight line add up to 180. So C2. That's C, nah? That is C, isn't? Yeah, C2. That's what we wanted. Is how much? 70. The last one, number 7, O3. Come on, they're playing with us. We got this as 140, so O3 is 40. Angle O3 plus angle O2 is equal to 180, adjacent supplementary. So we want O3 plus what's O2? 140, we got that, is equal to 180. So angle O3, 180 minus O3 is equal to 40 degrees. Now, there could be different ways of you doing it. This is just what I saw from the question that you gave. I don't know how much time we got. We've got like 7 minutes left. We got 7 minutes. Is our friend Hasanain back?
Question.
G. So if BOCD is cyclic, C1 is 40. If BODC is not cyclic. BODC is not cyclic. O does not lie on the circumference, my child. Ayanda Dladla says, can we not add another 10 minutes? Do you guys want a 10 minutes? How we would time there? Hasanain, we're getting requests to add another 10 minutes. Can we?
We got 6 minutes to go.
They're asking, can we do another 10 minutes?
I'm sure that shouldn't be a problem if you can do another 5 minutes.
Yeah. Come with Dala, one more cyclic. Come. One more, guys. One more. Okay. Kema says another 30 minutes, Hasanain.
Another 5 minutes, eh? I also got my studies. I've also got my examination to go. So
But
I'm
can you
also
imagine, Hasanain? They're sitting here for 2 days flat. They still want extra. They want more time.
next time, less jokes, more maths.
Yeah. No, never. We can't just Dala Mets one way. You go mad, Hasanain.
Yeah, I think that's your meaning of Dala maths. It comes with the jokes, flow jokes.
It must. Maths is funny.
Oh, I'm
And if we're
enjoying my
not
coffee now.
connecting with the people, we are in trouble, bruh.
I'm enjoying my coffee there.
Ish, it's vying down. It's hitting places here, bruh. This
Definitely.
coffee is scoping places. 1,
So,
2.
so Uncle Sadiq will be, Mr. Sadiq Isaacs is on camera now. He will be joining us shortly after your last
1, 2.
exercise. And
Yeah.
Mr. Sadiq will also be just adding some reflections of Maths Paper 1 and 2, as well
Excellent.
as an announcement of the competition, as well as a vote of thanks. So, Mr. Sadiq Isaacs, you're all good for that?
All good and ready, hasanain. All good and ready.
Okay, so we'll just give our facilitator, Mr. K, a little bit more time just to wrap
We're
up.
just finishing up. We're wrapping up. The last one we're doing for today. So they tell you E1 equals E2 equals X. So let's see. E1 equals E2. Right, that's what's given. So the minute they say, so E1 equals E2, which is equal to X. Right, so we got that. B3 is 90. B3 is 90. Interesting scenario. Prove that BE equals BC. Let's answer question number 1. Now, I don't have a memo. I've never seen this question before in my life. We're doing it for the first time. Prove that now come I tell you something. In order to prove BE equal to BC, that means they're asking you to prove that that's an isosceles triangle. That means we need to prove that angle C is equal to X. If we can prove C is equal to X, that means this is X, that is X. That means that's an isosceles triangle. Therefore, the two sides. So we're working backwards now. How do we prove that angle C is equal to X? Let's check. Let's check how is angle C equal to X. So this is 90. We've got a diameter. The diameter will subtend a 90 degrees there. So that angle there is also 90. Let's check. No, they're not. No, they're not. D1. Here's a cyclic. Now look. So obviously, what is A equal to? Because sum of angles of a triangle here is going to equal to 180 minus 90 plus X, which is equal to 180 minus 90 minus X, which is equal to 180 minus 90 is 90 minus X. So angle A is now called 90 minus x. Now this is a cyclic quadrilateral. So D1 is also 90 minus x. Exterior angle of a triangle, of a cyclic quad is equal to the interior opposite. And now we can find angle C and prove angle C to be x. So the first one is worth 8 marks. So let's get started with that. Where did we even start? What did we start with? We said angle B1 is equal to 90 degrees, right? Why? Angle in a semicircle, diameter subtends the 90 degrees. B1 is equal to 90, angle in a semicircle. Right. Then we said that angle A is equal to 180 minus 90 plus x. 180 minus 90 plus x. Sum of angles of a triangle. Sum of angles of a triangle. So this is equal to 90 minus x. That's angle A, guys. Therefore, angle D1 is also equal to 90 minus x. Exterior angle of a cyclic quad is equal to interior opposite. Exterior angle of cyclic quad equal to the interior opposite. Now we go in triangle DBC. In triangle DBC, angle C plus 90 plus angle B, that's the 90, plus 90 plus x is equal to 180. Sum of angles of a triangle. One thing, I'm a boss. Sum of angles of a triangle. Just joking. C plus 180. Check this one out, brah. Is equal to 180. So angle C. No, 90 minus x, sorry. 90 minus x. 90 minus x. That angle is 90 minus x. Minus x. So plus 180 minus 180 will cancel. The minus x will come on the other side. What is angle C equal to? Ding, 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 ding. What is C equal to? X. If this is x and that is x, therefore, triangle EBC is isosceles. Yo, how we crack that one? God loves me. Right, there we go. That one is isosceles. Therefore, that's the question. BE equals BC. Therefore, BE equals BC. Why? The sides opposite the equal angles. The sides opposite the equal angles of an isosceles triangle. Boom. How's that? Quite right. You see, the logic was I needed to find angle C to equal to x. Now we have to just fill out everything in our diagram to get C to equal to x. Because if C is equal to x, it's isosceles, therefore those two sides are the same. We're almost done. Prove that AE is a tangent. That one is worth 4 marks, 3 to 4 marks. Yes, Messiah. Angles opposite the equal sides or sides opposite the equal angles. Okay, we're wrapping up. We are wrapping up. Okay, so now we need to prove that AE is a tangent to circle EBC. Now there's no circle EBC, but they're telling us there's a circle EBC that exists. So where's E? EBC. So that means we must draw a circle around it. It looks like a potato. And prove that AE is a tangent. The only way to prove it's a tangent, angle between tangent and chord must equal to the angle in the alternate segment. Ding, 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 ding. That is equal to x. That is equal to x. We just proved. Therefore, tan chord theorem, AE has to be a tangent to that circle. So now, how do we write that out? So we say, we're answering question number 2. Angle E1 equals X, given. Angle C equals X, proven above. We just proved it to equal to X. Therefore, AE is a tangent to the circle EBC, to circle EBC. And the reason of that is the converse of tan chord theorem. Because the tan chord, if angle between tangent and chord is equal to the angle in the alternate segment, right? If there's a circle, then angle between tangent and chord is equal to that. But the converse of it, if the two angles are equal, therefore that line has got to be a tangent to the circle. And there we go. That's the wrap. That's the wrap. That's the wrap, guys. Yes, let's talk on Olo. E1 equals C1 equal X. Let's talk on Olo. You're a boss. Right. Lovely. We've come officially to the end of our session. I just want to say thank you to all of you. Love you lots from Kway and from Awqaf SA. And we'd love to see you guys. Please connect with us on the Facebook page. Connect with us. I hope you guys enjoyed this 2 days. It's been amazing. And we can't wait to engage with you again. So from my side, from Mr. K, thank you all. Hasanain, it's been amazing. Jazakallah so much. And thank you to Awqaf, and thank you to all the learners, all the schools, and all the teachers from around South Africa. Hope you guys learned a lot. And from me, Mr. K, Assalamu alaikum wa rahmatullahi wa barakatuh.
So there you have it. That was Mr. K, the man, the myth, the legend. Hope you enjoyed the energy. We definitely brought it. It was definitely magical interacting with you. You've been really amazing audience and very engaging. So we thank you and we wish you well for all of your examination preparation. And just bear in mind that subscribe to our YouTube channel. We will be having prelim and final exam workshops. So this is not the end of Awqaf's efforts to assist you. Kindly let your siblings know that we will be hosting a workshop for grade 12 that will be happening next week, the 20th and the 21st of May. This will be live from the Al Ghazali Hall. If you got any siblings in grade 12, please do come through. And that's also going to be with Mr. Kota. So before I give my final greeting to you, we're going to pass on the spot to Awqaf SA's Awqaf SA CEO Siddiq Isaacs, and he's going to address us now. Assalamu alaikum.
Alaikum salam wa rahmatullahi wa barakatuh, and good afternoon and hello again to everybody out there. One can scarcely believe that 2 days have gone by, and the one amazing thing is that there's still so much energy on this program. It's unbelievable. And the fact that somebody and more than one person is requesting for this program to be extended speaks volumes, absolute volumes, for the amount of learning that has actually taken place over the 2 days. And Mr. Kota, if that is the kind of reaction we're getting, we might have to employ you permanently at Awqaf. So well done to you. Really, we have to really take our hat off to you and to say a big thank you to you. We will do that again in the vote of thanks, but I can't help but say it right up front, because if people are asking for extra time, it means that they've had a real meaningful 2 days. And for me, that speaks volumes. And if that's the kind of feedback that we get, then really it must have been successful and has been successful. So yes, 2 days have gone by, and certainly I spoke yesterday about mathematics in terms of how important it is. And just to add on to that, you know, mathematics develops and helps to develop the brain in a very, very big way. It helps you with life skills. It even makes our people to become better cooks, whether you're female or male. It helps you to become a better cook because you've got to work out how much of the ingredients needs to be put in. If your calculation is wrong, wow, that food's going to come out not good on the other end, or it's going to come out brilliantly. And you're going to have a great business if you're going to become a cook. So this is what mathematics is all about: increasing your ability to solve problems easily, find solutions, and most importantly, maths will help you in a career. For those people who want to go and become pilots, who want to fly commercial aircrafts, remember, without mathematics, you will not be able to become a pilot. You need to work those calculations out. You need to be able to decipher where you are at any point in time, and you need to be able to understand how to solve those little problems in terms of numbers. So hopefully that's exactly what's happened. I'm convinced, and that is exactly what has happened. That has helped you certainly to a large extent. And so we wish you success. We wish you well over your exams coming up. And we certainly wish you well for 23 and lots of success going forward. Hasanain touched on the fact that we're not done yet. This is only the first 2 days of our mathematics program. We've got another weekend coming up next weekend in Pretoria. So please mention this to anybody who needs to be there for grade 12. And so then we move on to KZN in Durban, where we also have a mathematics program. So you can see that it doesn't stop here. It is a continuous thing, and we certainly flying Mr. Kota all over as well to make sure that he's with us and that he keeps this energy. He's certainly down to that 5 cups of coffee a day, without a doubt. So, Hasanain, special coffee on order for Mr. Kota, please, so that we make sure we keep that energy going. Then, just a reminder, don't forget, we've got our competition that comes up. It's important that you remember that we have this competition, because at the end of this year, going into 2024, we will certainly have the competition, and it is for the grades 10, 11, and 12, the math workshops that we're running. All registered participants will receive an email to enter. So no doubt you will get an email to enter. The competition will open in January 24. Once the grade 12 results have been released, there will be cash prizes, and we're looking at 1 or 2 other exciting prizes as first, second, and third prize, and the most improved. So keep tabs with us, stay connected. Details of that competition will be posted on the Awqaf website, and so stay connected with us to make sure that you're part of that competition. Finally, big thank you, really big thank you to Kway and Mr. Kota for the 2 days, which I believe was brilliant, and certainly very much a lot of learning that took place, but a lot of energy in terms of what went into those 2 days. The Awqaf staff in Johannesburg and in Cape Town, Ali, Hasanain, big thank you to Hasanain for putting this whole program together, Ali for helping set up in Johannesburg, and to any other staff of Awqaf who supported.
Thank you, Ali. You are a rock star, Ali.
Absolutely, absolutely. Then our DBE representative, Leonard Muda, who was there yesterday, and we hope to see him again next week. Big thank you to him for his support and for coming out all the way. ISkill and Farouk Lamalia for giving his support and being there to give us the necessary technical support. And then importantly, to our grade 11 participants and those 5 or 6 students that got up early this morning to be at the offices in 112 Barry Herzog. A big thank you to you for helping to make this a success, because without you, we wouldn't have the success that we had, and we wouldn't have the program if you were not there. So a big thank you for taking your Saturday and Sunday. It shows your commitment, it shows your dedication, and certainly shows your vision as to where you want to be in the future in South Africa. So we thank you. and we look forward to success for you, and we look forward to seeing you on our programs in the future again. Lastly, Awqaf will continue to play a key role in society, in communities as a whole, and mathematics is only one part of it. There is so many other fields that we do play in, and that we will continue to play in. So keep a watch out for all the events that Awqaf are involved in, and come and be part of that. Participate with us. Become a volunteer even with Awqaf. We're there to support you, and we're there to help South Africa take the next steps forward. So a big thank you to everyone again, and enjoy the rest of Sunday, and look forward to a great week ahead of us. Thank you very much.
So thank you. That was Mr. Sadiq Isaacs, Awqaf SA's CEO. He's been very instrumental in assisting us with the coordination and support for this program. And yes, Awqaf, we will continue with this program to build our country, to produce fantastic future leaders like Rory Sang and the like. And I'd like to thank Mr. Kota for his energy. I think in years to come, we will kind of actually look back at these important milestones, and Mr. K would have played a very instrumental role in producing doctors, scientists, lawyers, leaders of note. So a round of applause to you. This is a
I mean,
joint effort, and Awqaf likes to work jointly with service providers that has such high energy. So what I have done is, if you have registered and you were not able to attend the session, I have sent an email to all registered participants of the links of day one and day two. awqafsa.org.za. That is the website to look out for if you're keen to enter the competition, if you want to register for the other workshops. Mr. Kota will be next week in Pretoria, in-person thing. Please do come through, come and meet Uncle Sadiq, come and meet Mr. Kota, come and link up with me. I'll be linking up virtually. So that's it from me, Hasanain Abdullah from Awqaf's station here in Cape Town. It's been amazing. You've been an amazing audience, learners, your parents, as well as the educators. Mr. Kota, any concluding remarks? 30 seconds before we log off.
yes, absolutely. Jazakallah to all, and thank you to all our participants, parents, teachers, learners. Jazakallah to Awqaf for creating this. So hopefully, inshallah, one day this will be a legacy left behind to South Africa and to everybody long after my days are gone. And Jazakallah, Mr. Siddiq, for coming through today, putting this whole thing together, and the energy not only here, but the energy between us, between the partners, between Awqaf SA and Kway. We've got a long-standing relationship, and we pray to the Almighty that He takes us from strength to strength in the years to come. Learners, lots of love from Share the Care, from Kway and Awqaf SA, South Africa. Love you guys lots, and watch all the videos, and we wish you all the best in all your exams, and we hope to see you guys soon, inshallah. Once again, Hasanain, you've been an amazing co-pilot as usual, always keeping the vibe, always keeping us on track. Sometimes I could see you are also now falling off. I had to wrap you on your knuckles. We don't worry.
Coffee.
It's
Coffee. But don't worry, for the next sessions and the prelims, we'll make sure, like our CEO has mentioned, we'll have some caffeine kind of infused intravenously just to you, so you can keep up that energy.
We can only thank the Almighty that He's granted us these great opportunities, especially the digital, that we've crossed over the digital divide, that we are able to reach so many. This was always a dream, and we never thought, how would this dream ever be possible? And the way the Almighty had just put everything into place so that we could reach the numbers that we are, and we hope to reach much more.
So together we can rebuild South Africa. We can produce more excellence in scientists and engineers that's going to rebuild South Africa, and it's going to solve some of our problems. And this is our joint effort. So from all of us, we're going to be bid you good afternoon, and have a blessed evening with your family. and we wish you all the best for your preparation for the exams. We are behind you all the way. Assalamu alaikum wa rahmatullahi wa barakatuh.
Assalamu
That's it.
alaikum. Salute. Salute, Captain. Assalamu alaikum.
When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, and communities celebrate. Awqaf South Africa, a charitable Waqf organization, makes it easy to share the care. All donations are ploughed into Sharia-compliant investments, while the fruits support a wide variety of charitable causes. Visit awqafsa.org.za to discover how your Waqf can bless our community with a legacy of care.